Mr. Clay here for Clever Maths. This is your ultimate National 5 Maths 2025 exam prep guide. 4 hours of National 5 Maths going through topic by topic by topic by topic. Hopefully you find this useful, and if you want any extra help or any more help, then consider joining the channel, because I am doing an exclusive last minute live stream the night before the exam on Tuesday the 13th of May at 8 PM. It's only going to cost you £4.99, so sign up if you want to get on that or not. Take care and have fun with this. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code CleverMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code CleverMaths to get 30% off that. Link down below. Of total 40 marks it says. So question 1, evaluate 3.5 minus 1 1/4. Two ways to do this. You could take away the numbers and the fractions, but I'm just going to do it the way most people would do it, which is to make a fraction. So I do 3 threes is 9, 10, 11. So that's 11 thirds. 1 fours is 4 plus 1 is 5. So minus 5 quarters. So then we can make a common denominator. 3 fours is 12. 11 times 4 is 44. And 3 times 5 is 15. So I've got 15, 44 minus 15, 15, 25, 35, 45 is 29 over 12. Check if it's simplifiable. It isn't, because 29 is a prime number, but if you're not sure, change it back. 12, 24 is 2. 25, 26, 28, 29, that's 5 12s. 2 and 5 12s. I'll do it the other way just to be on the safe side. 3 minus 1 is 2. 2 thirds minus 1/4. Common denominator equals 12. 2 fours is 8. 1 threes is 3. 8 minus 3 is 5 12s. So I get 2 and 5 12s. Exactly the same answer. So we're done there. 2022, just last year, paper 1, question 1, evaluate 2/5 times 1/5 plus 3/4. So again, BIDMAS brackets first. 1/5 plus 3/4. Common denominator is 20. 1 times 4 is 4, plus 3 times 5 is 15. 19 out of 20. So we've still got this 2 thirds to times by. So step 2, 2 thirds times 19 over 20. 2 times 19 is 38. 3 times 20 is 60. And they are both even, so I can divide by 2 to simplify. A half of 38 is 19, and a half of 60 is 30. 19 is a prime number, it doesn't go into 30, so that's me simplified for my final mark. SQA National 5 Maths 2023, paper 1, question 1. 2 1/6 divided by 8/9. So we've got dividing fractions, so we'll make a top heavy fraction. So I'm going to do 2 times 6 is 12 plus 1 is 13. So that becomes 13 over 6. Divide means you times by the reciprocal. So I times by 9/8, taking it upside down. Now you can either simplify now or simplify later. I'm just going to simplify at the end to make it simple. So I'm going to do 9 times 13. Well, 9 times 10 is 90. 9 threes are 27. So that is 90, 100, 110, 117. Out of 48, because 6 times 8 is 48. So now we have to simplify our answer. 3 goes in each of these numbers, so I'll divide the top by 3 and the bottom by 3. 3 into 11, well, 3 threes are 9. 10, 11 makes 2. 3 nines are 27. And 3 into 4 goes 1, 1 left over, 3 sixes are 18. So 39 over 16. You could leave your answer as a top heavy fraction, but I'll just change it back just to be on this clear side, or in case you did that anyway. So 16, 32 makes 2,
33, 34, 35, 36, 37, 38, 39 makes 7 out of 16 left over. And you should be able to see that that is simplified. Just a quick note on this one. Back at the start here, you could actually simplify in advance if it's a times sign here by dividing by 3 over here and dividing by 3 over here, one on the top, one on the bottom. And that would give you, to start with, 13 times 3 on the top divided by 6 divided by 3 is 2 times 8. 3 13s is 39 and 2 8s is 16. So you get to 39 over 16 a little bit quicker, a little bit easier.
Question 1. Dougie pays £460 for a new laptop. It's expected that the value will depreciate by 26% each year. Calculate the expected value after 3 years. So 100% minus 26%, 100, 90, 80, 74%. And that is 0.74. So you just do 460 times 0.74 to the power of 3 in your calculator. And we get 186.403, but 2 decimal places for money, so 186.40. 186.40, and we're done there. SQA National 5 Maths 2023, Paper 2, Question 1. A caravan was bought for £20,000, depreciated by 11%, then it depreciated by 6% for the next 2 years. What's it worth after 3 years? So if it went down by 11%, 100 minus 11 is 90.89%, which is 0.89. And 100 minus 6 is 94%, which is 0.94. So I need to do £20,000 times 0.89 for the first year times 0.94, but to the power of 2 because that's over 2 years. That gives us a total of 15,728.08. SQA National 5 Maths 2024, Paper 2, Question 5. This year, the cost of Charlie's car insurance is £278.40. This is an increase of 16% on last year's cost. Calculate the cost of Charlie's insurance last year. No time means divide. Is what I usually tell people if it's not a basic percentage question. So there's no time, so I'm not doing appreciation. So it means I'm doing a reverse percentage. So let's see. This is an increase of 16% last year. So last year it was 100%. So that means that 278.40 equals 116%. So to work that out really quickly in a calculator, I just do 278.40 divided by 1.16 as a decimal, divide by 100 first. Which is £240. And you're done there. Or you could divide by 116 and times by 100, same idea.
10. Tommy buys flower seeds from a website. He's given a 30% discount. He pays £16.10. Calculate the cost without the discount. No time in this question, so I'm probably dividing. So 30% discount, which means 100% minus 30%. That means he's paid 70%. So we know that 70% represents £16.10. We could go down to 10% and back up to 100% hopefully. So let's just go down to 10%, divide by 7 to give me 10%, divide by 7. So that gives me 7 2s are 14, 2 left over, 7 3s are 21, and 0, £2.30 for 10%. So 100% must be £23.
SQA National 5 Maths 2024, Paper 2, Question 2. An ant colony occupies an area of 50 hectares, and there's an average of 1.22 times 10 to the 6 ants per hectare, so in 1 hectare. Calculate the number of ants in the colony. Well, the ant colony occupies an area of 250 hectares. That's per hectare, so it's just times 250. Times 250. Now, your answer is to be in scientific notation, but it might give you it without scientific notation to start with. So then I change that by writing 3.05 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. And we're done there.
SQA National 5 Maths 2023, Paper 2, Question 2. The mass of helium atom is 6.64 times 10 to the minus 24. A flask contains 300 grams of helium. How many atoms are in the flask? So to get the number of atoms in the flask, I need to do 300 grams divided by 6.64 times 10 to the minus 24. So since these numbers are so big, chances I calculate will just give you the answer in scientific notation. Mine tells me it's 4.51807, bunch of other numbers, times 10 to the minus 23. Give you the answer to three significant figures. So that's 4.52 times 10 to the minus 23. And we're done there.
National 5 Maths 2024 Paper 1 Question 6. Simplify root 75 minus root 3. So root 75 is a surd that I can simplify because it's got two square numbers at times together, and I've got 25 and 3. So square root of 25 is 5, so that's 5 root 3. So my sum is 5 root 3 minus a root 3. Don't be tempted to write 5 here. It's 5 root 3 minus 1 root 3, which is 4 root 3. And we're done there.
Band and simplify. So we've got root 10 times root 10. Well, that's just 10. We've got root 10 times root 2. Well, that's going to be root 20. 2 tens are 20. And we've still got plus 8 root 5. So at this point, we need to check if root 20 can be simplified as a surd. We're looking for two numbers that go into 20. One's a square number. Hopefully it'll be 5. Let's just check. Root 20 equals root. Well, 4 is a square number times 5. So that gives me 2 for square root and 4, root 5. So I can rewrite my problem as 10 minus 2 root 5 plus 8 root 5, which equals 10. 8 minus 2 is 6, so plus 6 root 5. And we're done. Can't add the 10 and the 6 root 5 because they're, well, different from each other. One's a whole number, one's got a root in it. SQA National 5 Maths 2023, Paper 1, Question 8. Express 12 over root 15 with a rational denominator. So I need to rationalise the denominator. So I do 12 over root 15 and I times by root 15 over root 15 and eliminate the denominator's root. So on the top, to start with, that gives me 12 root 15. And on the bottom, I just get 15. So then I always simplify my answers. So I can simplify the outside fraction, 12 and 15. I can divide that by 3. So dividing the top and bottom by 3, I get 3 into 12 goes 4, root 15. 3 into 15 goes 5. Do not be tempted to then divide the 15 by the 5 or anything, because that's under a root, but that is not. Just a quick check, is root 15 a simplified surd? Well, that means, is there any square numbers that go into it? Well, 4 doesn't go into it, 2 2's a 4, 9 doesn't go into it, 3 3's a 9, and 16 is too big, so I'm done there.
SQA National 5 Maths 2019 Paper 1 Question 12. Express root 2 over root 40 as a fraction with a rational denominator and give it in its simplest form. So we've got root 2 over root 40. You can simplify now or after. So we'll simplify after. Root 40 over root 40. That gives me 2 times 40 is 80. So root 80 on the top. And root 40 times root 40 is just 40. So simplifying our root 80. I'm looking for two numbers at times to make 81's a square number. The biggest you can find. 16 goes into it 5 times. So that is 4 root 5. So our final answer is 4 root 5 over 40. 4 goes into 40 10 times, so that's root 5 over 10, and we're done there. SQA National 5 Maths 2024 Paper 1 Question 13. Expand and simplify fully. So I've got x times x to the half, so that's a power 1. So I add the powers. So that's x to the 1 plus a half, which is 3 halves. And then I've got this 1 times this 1. Well, 1 plus minus 1, 1 minus 1 is 0. So plus x to the 0. So that's x to the 3 halves. Anything to the power of 0 equals 1. And we're done there.
SQA National 5 Maths 2023, Paper 1, Question 12. Simplify 5c to the minus 2 over c cubed times c4. So start off by doing my timesing. Times means you add if the base is the same. So cubed times 4, 3 plus 4 is 7. So I write c7 on the bottom. So now divide means take away. So I've got 5 still, nothing happens with that. Minus 2, take away 7 is minus 9. And then our final mark. A negative power means I can do 1 over the positive power, so the 5 stays where it is, and the c goes on the bottom with a positive 9, and we're done there.
Okay, laws of indices, SQA National 5 Maths 2015, Paper 1, Question 14. Evaluate 8 to the power of 5 thirds. Now, it's a non-calculator question, so we're going to have to change it into a format we can work on. So, 8 to the power of 5 thirds, from the laws of indices, that is a root. And what type of root is it? Well, the bottom number tells us cube root, and the 8 and the 5 go along underneath the root. So it's the cube root of 8 to the power of 5. So I can either cube root first or after the fact. Might as well do it first because 8 to the power of 5 is a hard sum. So the cube root of 8 is 2 times 2 times 2 is 8. So that gives me 2 to the power of 5 still, because it's just the cube root of 8 I've done. 2 to the power of 5. That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and we're done there. Okay, laws of indices, SQA National 5 Maths 2019, Paper 2, Question 16. Simplify a to the 4 times 3a all over the square root of a. So let's just write that out, a to the 4 times 3a, all divided by the square root of a. Well, let's deal with the top first then. 3 is just times by 1, which is 3. And then the powers, I can put a little 1 on this and add the powers. Law 1. 4 plus 1 is 5. So I get a to the 5, and that's over the square root of a. Now, to divide by the square root of a, I'm doing indices, so I need everything to be indices. So that's going to be 3a to the 5 all over a to the half. The square root of a is a to the half. And now I'm dividing indices, so I can take away the powers. So that is 3 to the a, and it's going to be 5 minus a half is what I need to do. Now 5 minus a half, I want it all in fractions. So I will change that to 3a, and you might know this already, but 5 is 10 halves minus 1 half to be very clear. So that gives you 3a to the 9 halves. Now you could leave your answer like that because it says just simplify. It doesn't say put it back in a root. But if you were to put it back into a root, it would be 3 times the square root of a to the power of 9 would be your final answer. SQA National 5 Maths 2024, Question 3, Paper 1, Question 3. X plus 1 times x squared minus 4x plus 5. So I usually draw a box for these. X plus 1, x squared minus 4x plus 5, expanding it all. And then we've got x times x is x cubed, minus 4, x squared, 5x is 5x, 1x squared is just x squared, 1 times minus 4x is minus 4x, and 1 times 5 is plus 5. So I've got x cubed, minus 4x squared plus an x squared is minus 3x squared, 5x minus 4x is 1x, and then a plus 5 on the end, and we're done there.
SQA National 5 Maths 2023, Paper 1, Question 2. Expand and simplify, so an expand and simplify question. So we've got x plus 7 squared plus 6 times x squared minus 10. I'll do this in the same way I always do it, using the box method, but you could have done it any other way. So x plus 7 squared means I've got x plus 7 times x plus 7. You expand that bracket, plus 6 times x squared minus 10. X times x is x squared, plus 7x. 7 times x is plus 7x. 7 sevens is 49. Plus 6 times x squared is 6x squared. 6 tens is 60, taken away. So now I can just put everything in the boxes together. So looking at the x squareds first, I've got 1x squared plus 6x squared, so that's 7x squared. Looking at the x's, 7 and 7 is 14x, no other x's, so plus 14x. And finally, I've got 49, take away 60, so that's negative 11. And we're done there.
SQA National Maths 2016, Paper 2, Question 4 on factorising. Factorise through with 3x squared minus 48. Well, first thing we check if there's a common factor. Well, there is. 3 is a common factor, so I can divide by 3 to get x squared. And 3 into 48, well, 3 into 4 goes 1, with 1 left over. 3 6s are 18. So we get 3 bracket x squared minus 16. But that's a difference of 2 squares. So how do you factorise that? You know it's a difference of 2 squares because you've got an x squared or something squared, and then take away a number, which is a square number. So that's just double brackets. X in each place, square root of 16 is 4, so that goes in each place, plus in one bracket, minus in the other, and you're done there. Solving quadratic equations by factorising. SQA National Maths 2018, Paper 1, Question 5. Solve x squared minus 11x plus 24 equals 0. So you should recognise that's a quadratic or trinomial because it's got an x squared, an x, and a number. So since it's Paper 1, I know we're factorising most of the time because if we use the quadratic formula, we're going to get decimals. So unless it tells us to in Paper 1, factorises. Looking for a common factor, there's no common factor, so straight away it is double brackets. And this is quite a simple one. If it's just an x squared, I can write x and x straight away. To get my other numbers, I'm looking for two numbers at times to make 24, but add to make minus 11. So at the side, what you could do is write minus 11 and 24. Writing down all the factor pairs of 24, so 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I'm done. And you're looking for those pairs, can I add or take away to make minus 11? Well, I clearly can't do that with 24 and 1. I can do it with 12 and 2. No, can't do it. Can I do it with 3 and 8? Well, 3 plus 8 is 11, so yes, I'm going to be able to do it. And can I do it with 4 and 6? Nope. So how do I do it with 3 and 8 to make minus 11? Well, I need minus 3 and minus 8 to make minus 11. And just double check at the end. Minus 3 times minus 8 is 24. So I've done it right. Minus 3 minus 8. So we've got two brackets that equal 0. That means that x minus 3 equals 0 or x minus 8 equals 0. And just solving those equations, x must be 3 because 3 take away 3 is 0. Or x must be 8 because 8 take away 8 is 0. And we're done there. SQA National Maths 2024, Paper 2, Question 12. Express that as a fraction in its simplest form. Right? Just imagine there's brackets around this. We're adding fractions, so common denominator. Times them together, x plus 5 over n x minus 4. This times this then, 2x minus 4, plus this times this, 3x plus 5. So that gives me, expanding the top, 2x minus 8 plus 3x plus 15 all over x plus 5x minus 4. 2 plus 3 is 5x. 15 minus 8 is 7 over x plus 5x minus 4. Let's just double check that. 2 times x is 2x, 2 4s is 8 minus 8, 3x plus 15, 2x plus 3x is 5x, and 15 minus 8 is 7, 8, 9, 10, 11, 12, 13, 14, 15. So now the only way to simplify that further is to check, is there a common factor on the top? Well, there's no common factor between 5x plus 7, so I'm not going to get anything I can cancel, so I'm done there.
SQA National 5 Maths 2023, Paper 2, Question 10. Express 7 over x minus 3 minus 2 over x as a fraction in simplest form. So 7 over x minus 3 minus 2 over x. I'll put brackets around that. Common denominator means we times these together. So our x over x minus 3. So we can do this one's been times by x. So it's 7 times x is 7x. And this one's been times by x minus 3. So let's take away 2 times x minus 3. Brackets are important. So then we can expand the brackets on the top. 7x minus 2x minus 2 times minus 3 is plus 6. No need to expand the bottom. So that gives me 7x minus 2x is 5x plus 6 over x, x minus 3. And we check if we can factorise the top to simplify further, but we can't, so we're done. If you expanded that to x squared minus 3x, you'd probably be fine as well. Question 12. Express that as a single fraction in its simplest form, algebraic fractions. X plus 2 squared. So x plus 2, and it's a divide. So the first thing we're going to do is get rid of that divide. So we've got 4 over x plus 2. Divide means we change to our times, and we flip the second one upside down. And now we can simplify and advance as normal. So we've got x plus 2 and x plus 2 on top and bottom, so I can take one of them away, and that just leaves x plus 2. And then we can answer the question. You've got 4 times x plus 2 over 5. And we're done. No need to expand the bracket because it's already simplified. It doesn't make it any simpler. SQA National Maths 2018, paper 2, question 15 on algebraic fractions. Express n over n squared minus 4 divided by 3 over n minus 2. It tells us that n cannot be minus 2 and 2 because the denominator will be divided by 0 as a single fraction in simplest form. Dividing by a fraction is the same as timesing by its reciprocal. So times, and then the second one flips upside down. So that becomes n over n squared minus 4 times n minus 2 over 3. So now we can just times the top and times the bottom. Now when I times the top, I would not actually times it, I would keep it factorised because you're going to factorise the bottom to simplify. So that gives me n minus 2 over 3 times n squared minus 4. So far so good. But n squared minus 4 is a difference of 2 squares. So we can factorise n squared minus 4. Just a reminder of that one. I've got the 3 still hanging out. But double brackets, you square root the first thing, which is n. And you square root the 4, which is 2. And minus in one bracket and plus in the other. So you should notice I've got a same bracket top and bottom, so I can cancel them out. We very clearly show that by saying that that's gone and that's gone. So now we've got on the top just n, and on the bottom 3 bracket n plus 2. And there's no more way to simplify that, so we're done there.
Maths 2024, paper 2, question 6. Factorise y squared minus 6y. Common factor is y. Bracket y minus 6. Done. Hence simplify this. So I already know the top is y minus 6. So I need to factorise my bottom. So I check for a common factor, y squared minus 3y minus 18. No common factor, so it's double brackets. Now, you should be able to surmise or guess that you're going to get y minus 6 in one of them. But let's just check. You get y and y. And if you're not sure, you're looking for two numbers that times the 18, but add to 3. Just have a little note where minuses. So 1 and 18 doesn't make 3. 2 and 9 don't add or take away to make 3. 3 and 6, well, they do add or take away to make 3. So I want minus 3. So it's minus 6 plus 3 is minus 3. So in one bracket, I get minus 6. In the other bracket, I get plus 3. And now we can just simplify by same brackets, they disappear to get y over y plus 3. Do not be tempted to then simplify the y's because the plus anyway, you can't do that. You're finished there, and that's us done. Fractions and factorising. So routine factorising, SQA National Maths 2017, paper 2, question 9. Part A, factorise 4x squared minus 25. So when I'm going to factorise something, I see if there's a common factor. Common factor for 25, there's no common factor, so it's definitely double brackets. So I can do my double brackets straight away. And this is called a difference of 2 squares because it has got a minus, it's got 2 things, it's got an x squared, and then it's got just a number. So I square root the first term, 2x, and a square root the last term, 5 and 5. And then it's just plus for one of the brackets and minus for the other. And we're done there. Part B, hence simplify 4x squared minus 25 over this other quadratic. So we've already factorised the top, so let's factorise 2x squared minus x minus 10. There's a number of ways you can do this, but one of the simplest ways is to times the 2 and 10 together. So I'm looking at 2 times 10 equals 20. And I'm looking for numbers that times together to make 20, but add together to make minus 1, which is the middle term. Now, really it's minus 20, but I'll just do 20 and then I'll fix it later. So I've got 1 and 20 I could pick. 2 times 10 is 20. 4 times 5 is 20. And that's them all. So 1 and 20 I can never add or take away to make minus 1, so it's not that one. 2 and 10 I still can't do, so it's 4 and 5. And how do I make minus 1 from 4 and 5? Well, it must be plus 4 take away 5, and then just double check. 4 times minus 5 is minus 20, which is what I want, minus 20. So now I can take my 2x squared minus x minus 10 and rewrite it as 2x squared plus 4x minus 5x, just splitting that middle term, minus 10. And then you can imagine an imaginary line down here. You're going to factorise each side. So factorising the first side, 2 is a common factor, but so is x. So I get x, 2x times x is 2x squared, plus 2x times 2 is 4x. And then the other side has to have the same bracket again. So I'm just going to write x plus 2 and work backwards. So I've got 5, so I need 5 times x, but it's minus. So it's probably going to be minus 5, and just double check. Minus 5 times 2 is minus 10. So that means in fully factorised form, I can double bracket it to get x plus 2 for one of my brackets, because that appears twice. And then what's outside the bracket? 2x minus 5. So I can write 2x minus 5. So going back to our question, now that I factorised that, we had 4x squared minus 25 over the quadratic. So let's just write that again. 4x squared minus 25 over 2x squared minus x minus 10. Well, that's going to equal, factorise the top already, was 2x minus 5 and 2x plus 5. And the bottom we've just factorised to get, I'm going to write the 2x minus 5 first, so it's really clear, and x plus 2. Doesn't matter the order you write your brackets. Now, you should be able to see that you've got the same bracket top and bottom, so they cancel each other out. These don't cancel because they're not the same. So our final answer is simply 2x plus 5 on the top and x plus 2 on the bottom, and we're done there. Question 2, given f of x is x plus 3 squared, find f of 7. Well, f of 7 means I sub in 7. So I've got 7 plus 3 all squared. 7 plus 3 is 10. Squared is 100. 10 tens is 100. Oh, we're done there. And finally, for functions, National 5 Maths 2022, Paper 1, Question 2, just last year. F of x is x cubed minus 2. Find f of minus 3. F of minus 3 equals minus 3 cubed, take away 2. Minus 3 cubed, well, 3 times 3 is 9, times 3 is 27. So that gives me negative 27, take away another 2, which is negative 29. National 5 Maths 2018, Paper 2, Question 6. A function is defined as f of x is 5 plus 4x. Given f of a is 73, calculate a. So this is the one where you have to solve an equation. So we've got 5 plus 4a, because it's changed the letter, equals 73. Taking away 5 from both sides, 4a equals 73, take away 5. That gives you 68. So a is 68 divided by 4. And again, you can just calculate for this one because it is a calculator paper. But 4 goes into 6 once. 4 sevens is 28. You would get 17 as your final answer.
Find the equation of a line passing through those points and give it in simplest form. So we need the gradient first. So gradient is y2 minus y1 over x2 minus x1. So that's x1, y1, that's x2, y2. So that gives me 7 minus minus 1 on the top, and minus 5 minus minus 3. That gives me 8. Minus 5 add 3 is minus 2. That gives me minus 4. Now we use y minus b equals mx minus a, or y equals mx plus c. So I'm going to just pick a point for a and b. I'll just pick the second one, a and b. Y minus 7 is minus 4 x minus 5. Watch out for minuses. Y minus 7 is minus 4 x plus 5. Y minus 7 is minus 4x minus 20. So y equals minus 4x minus 20 plus 7 is minus 13. And we're done.
SQA National 5 Maths 2024, Paper 1, Question 9. In a car rally, competitors start at different times. Scatter graph shows the relationship between the length of time they have been driving in t minutes and the distance in kilometres to the finishing line. A line of best fit is drawn. Point A represents 3 minutes and 26. So that's 3:26. I'll take a note of that. Point B represents 10 minutes and 12 kilometres. 10 minutes and 12 kilometres. Find the equation of a line of best fit in terms of d and t. Okay, so it's an equation of a line. So I need the gradient, which is y2 minus y1, x2 minus x1. So I'll just call the first point x1 and y1, and the second point x2 and y2, or the other way around. So I've got 12 minus 26, just watch out for minuses, over 10 minus 3. And I'm expecting a negative answer because it's sloping down the way. So 12 minus 26, 12, 22, 23, 24, 5, 6 is 14. So I've got minus 14 all over 3. 10 minus 3 is 7. That is minus 2. And now the equation I use is always y minus b equals mx minus a. You might have been taught to use y equals mx plus c, but you'll get the same answer. So I'll pick one of the points to be a and b. It doesn't matter which, so I'll just pick the 10 and the 12. Y minus 12 equals minus 2x minus 10. Y minus 12 equals minus 2x, and a minus times a minus is a plus. Watch out, plus 20. So y equals minus 2x, 20 minus 12, so I'll add 12 is 32 plus 32. And I'd usually be done there, except the axes is not x and y, is d and t. So y becomes d equals minus 2. Is that a big T? Yeah, it is. T plus 32, and that's my final answer, and we're done there. Another competitor has been driving for 7 minutes. Use your equation to estimate the distance the competitor is from the finishing line. So I've got d, remember, is minus 2t plus 32, and they're telling me that t equals 7. So that means that d equals minus 2 times 7 plus 32. That's minus 14 plus 32. So I need to do 32 minus 14. So 24, 25, 26, 28, 29, 30, 31, 32, 18. 18 kilometres. Get your units in there. That is kilometres, isn't it?
SQA National 5 Maths 2023, Paper 1, Question 7. A business records sales of a sample of its employees in the length of time they worked for the business. The scatter graph shows the relationship between their salary and the time and years they worked. The line of best fit is shown, so it's a straight line question. Find the equation of a line of best fit in terms of P and T. Give the equation its simplest form. So to find the equation of a line, you need to find the gradient, and then you need to use the formula y equals mx plus c, or y minus b equals mx minus a. So I need the points for gradient, so let's pick some points. There's one clearly there. That is 5 to 1,000. 20,000, sorry. And the second point we can pick is clearly identified here, which is 25, 50,000. So starting off with our gradient, y2 minus y1, x2 minus x1, that's x1, y1, that's x2, y2. So that gives me 50,000 minus 20,000 divided by 25 minus 5. So that's 30,000 on the top divided by 20 on the bottom. Quite a big number to deal with, but we can get rid of the zeros to start with. And that gives me 3,000 divided by 2, which is 1,500 or 1,500. So there's our gradient. So now we can do y minus b equals mx minus a is how I usually do it, or y equals mx plus c if you prefer. So there's our straight line, and I'm going to use the point A and B, positive numbers, so nice and straightforward. Y minus 20,000 equals 1,500 times x minus 5. Don't be worried about the big numbers because it ends in zeros, so we can deal with that. So that's y minus 20,000 equals 1,500x. And we need to do 5 times 1,500, so 5 15s is 75, so minus 7,500. Adding 20,000 to both sides, we get 1,500x. 20,000 minus 7,500 is 12,500. So there we go in terms of y and x. But our graph is in terms of p and t, p and time. So we need to change the y-axis to p equals 1,500t plus 12500. Just make sure it's a capital T. It is. So we're done there. Part B, use your equation from Part A to estimate the salary of an employee who has worked for the business for 8 years. So remember, our P was 1,500t plus 12,500. And they're saying that 8 years, so that means that the pay is 1,500 times 8 plus 12,500. Okay, 8 times 1,500, so if I double it, I get 3,000. Double again, 6. Double again, 12. So I get 12,000 plus 12,500, which is equal to, with a pound sign, £24,500. Let's see if that agrees with the graph. That looks about right, so we're done.
SQA National Maths 2024, paper 1, question 11. A straight line has an equation x plus 4y minus 24 equals 0. Find the gradient. The gradient is the number in front of x, but only when it says y equals, so I need to rearrange. So I'll keep the 4y where it is. And I'll just move that x, so that's positive, so I'll make it negative x on the right, and minus 24 is plus 24. And now I can divide everything by 4, so I get minus a quarter x. 4 5s are 24, 6s are 24, and that means the gradient, I'll write gradient, I suppose, which equals m, is minus 1/4. And we're done there.
Simplify Maths for 18, paper 2, question 14 on a straight line. A straight line has this equation, 2x minus 5y equals 20. Find the coordinates of the point where the line crosses the y-axis. Cuts the y-axis when x equals 0, the opposite. So y-axis when x equals 0, so I'll just sub it straight in, there's no need to rearrange here. When x equals 0, I've got 2 times 0 minus 5y equals 20. So that's minus 5y equals 20. Divided by minus 5, y is minus 4. So to put my coordinate, that as a coordinate, remember x and y, x is 0, y is minus 4, and I'm done there.
National 5 Maths 2019, paper 1, question 14. Solve this equation. So again, the lowest common multiple between 2 and 5 is 10. So if I times everything by 10, I'll be good to go. So I've got 10 times x over 2 minus 10 times 1 equals 10 times 3 minus x over 5. Simplifying our fractions, we get 10 over 2 is 5, so that gives me 5x minus 10 equals 10 over 5 is 2. And now we can solve the equation as normal. 5x minus 10 is 6 minus 2x. Taking the x's over to the left, adding 2x gives us 7x minus 10 equals 6. So 7x equals 16. And therefore, final answer is x equals 16 over 7. Check that it's simplified. It is, so I'm done. Okay, a little bit harder this one. 2022, paper 1, question 15. A triangle and rectangle are shown. Find an expression for the area of the triangle. So the area of a triangle is a half the base, which is 3, times the height. Don't be worried that the height is algebraic, x plus 12. So that's an expression. We can simplify that a little bit. That's 3 over 2, x plus 12. And that is a fine answer, but I'll go ahead and multiply out the brackets. We get 3 over 2, x. 12 divided by 2 is 6 times 3 is 18. So there's my area of my triangle there for our mark. And then part B says, given the area of the triangle is equal to the area of a rectangle, find the value of x. So we already know the area of a triangle is 3 over 2, x plus 18. And that equals the rectangle, this times this. So in other words, 6 times 8 minus x. If we can get that far, then we're good to go. We just need to solve our equation, okay? So let's start working on this. We've got 3 over 2x plus 18 equals 48. 8 times x is 6x. Times and through by 2, I'll write that here, 3 over 2x plus 2 times 18 equals 2 times 48 minus 2 times 6x. Make sure you times everything by 2. So that gives me 3x plus 2 times 18 is 36. 2 times 48 is 96. And 2 times 6 is 12. So we get to a simple-ish equation, moving the x's to the left-hand side. We get 15x by adding 12 plus 36 equals 96. So 15x equals 60. Dividing through by 15, we get x equals 4. That's 2024 paper 2 question 4. Solve algebraically via an equation. So we've got 5x minus 2 plus 4 is less than 7x plus 8. So expand the bracket. I'm not going to use a box for this one. 5x, 5 2s are minus 10 plus 4 still, less than 7x plus 8. Collect like terms. 5x minus 10 plus 4 is minus 6, is less than 7x plus 8. Now I like to keep my x's positive. So I'm going to move the 5x to give 2x on this side plus 8 is less than, minus 6 is less than that. Move the 8, so it's minus 8. Minus 6 minus 8 is minus 14 is less than 2x. And divide by 2, minus 7 is less than x. I have solved it. You'd probably find like that, but to write it the right way, just flip the sign. X is greater than minus 7. Now you would have also had to flip the sign if you had done your x's on this side, because you would have ended up with a negative x, and when you divide by a negative, you flip the sign.
SQA National 5 Maths 2023, paper 1, question 14. Solve algebraically this an equation. So we've got x plus 1 over 3, take away 2 is greater than 3x over 5. Now we put brackets around that so we don't miss anything. So we can do it in one step or two really. You can times by 3 and then times by 5, or 3 5s is 15, so I'll just times by 15. So I'm timesing everything by 15, the left side and the right side. So I'm going to times this by 15, which means that gets times by 15, which means this gets times by 15. So I've got 15x plus 1 over 3. 2 15s is 30, is greater than 15 times 3 is 45. X over 5. And then we can simplify these fractions to get rid of the fractions completely. 3 goes into 15 5 times, so we've got 5x times 1 plus 1 minus 30 is greater than 5 9s are 45, 9x. Expand the bracket, 5x plus 5 minus 30 is greater than 9x. So you've got 5x, 5 minus 30 is minus 25, is greater than 9x. Collecting our terms, so I'll take the 5x over to the other side to have minus 25 is greater than 4x. And then dividing through by 4, I've got minus 25 over 4 is greater than x. If that's simplified, we're fine. 4 5s are 24, 6 are 24. Or, if you want to write x on its own on the left, you don't have to, then the sign changes to minus 25 over 4, and it becomes less than.
SQA National 5 Maths 2024, Paper 2, Question 9. Change the subject of the formula to D. So I've got f 2d plus 3 over e. So let's just times them together. Fe, or ef, is 2d plus 3. Take away 3. Fe minus 3 equals 2d. So divide by 2. Fe minus 3 over 2 equals d. Or just to tidy that up, d equals fe, or ef, minus 3 over 2. ef or fe. Usually alphabetical order is nicer than none, but it doesn't really matter actually. SQA National 5 Maths 2023, Paper 2, Question 7. Change the subject of the formula P equals a third of mn minus r to m. So let me just write that one out. 1/3 mn minus r. Okay, so let's collect some terms to get the thing with m on its own. So I want to add r to both sides. So p plus r is a third of mn. And now we can deal with this fraction because we've got m on its own. We've connected to a bunch of stuff. So if I times both sides by 3, I'll get 3 times p plus r equals mn. And we want to change it to m, so we get 3 times p plus r over n equals m. Or m is 3 times p plus r over n. We could expand the bracket as well. If you did that, you would get 3p plus 3r over n, but we should be need to do that. Paper 1, Question 14. Change the subject of the formula to x. But again, we've got a root involved. Now, when it's a root, but if there's other things in the question, it's sometimes better to make the root the subject and then square at the end. It just eliminates any problems you're going to have. So, I'm going to make the root x the subject. So I'm going to take away h to start with. So y minus h equals g root x. Dividing by g, we get y minus h over g equals root x. And now, since we've eliminated everything and we've got root x on its own, we're going to square both sides. So we can just write a big bracket, y minus h over g squared. The whole thing's getting squared. Equals x. And we're done. Okay, changing the subjects, but when there's squares and square roots involved. So this is 2016 Paper 2, Question 12. Change the subject to k, but there's a square root. So I'm going to have to eliminate that square root. Well, the opposite of a square rooting is to square. So I'm just going to square both sides. So that gives me L squared. And when you square a square root, this root just disappears. So it gives me 4kt minus p, whatever's under that root. Now I can change it to k in the same way, adding p to both sides. I get L squared plus p is 4kt. Dividing through by anything which is attached to that k, which is 4 and t this time, we get L squared plus p all over 4 and t equals k. Or you can write it the other way, k equals L squared plus p over 4t. SQA National 5 Maths 2024, Paper 1, Question 7. Solve algebraic with a system of equations. So it's simultaneous equations with equations given. I always get rid of the second one, so that's what I'm going to do. But if you got rid of the first one, you should get the same answer. So you times this one by 2 to make 14r, and times this one by 7 to make 14r. 2 2s is 4p, 2 7s is 14r, and 2 11s is 22. And then the bottom one, 7 3s is 21p. 7 2s is 14, that's an r by the way, 14r, and 7 4s is 28. So now, if the signs are the same on the one you're getting rid of, you add. If they're different, you take away. So I need to add these together. 21 plus 4 is 25p, and that equals 28 and 22, which is 38, 48, 49, 50. And therefore, p is 50 divided by 25. So p equals 2. And now you just sub in any equation you want. I usually just pick the first one. So picking the first one, we've got 2p, 2 times 2, minus 7r equals 11. So that's 4 minus 7r equals 11. 11 minus 4 then, taking away 4 for both sides. 11, 10, 9, 8, 7. You get minus 7r equals 7. So r is minus 1. No other statement to make for this question, so we're done there.
Simultaneous equations for question 4. After writing an equation, 4 mangoes and 3 apples, 4 mangoes, 3 apples equals £4.25. Quite standard. Part B, 5 mangoes plus 2 apples equals £4.70. I have to find the cost, part C, of a mango and an apple. So I've got my two equations. We've got 4m plus 3a is £4.25. And we've got 5m plus 2a is £4.70. Times the top by 2 and the bottom by 3, just to get 6 in the second position. So that gives me 8m plus 6a equals 8.5, and it gives me 15m plus 6a equals 3 sevens is 21, 3 fours is 12, 13, 14.10. I'll call that equation A and B, and we're going to do B minus A because the signs are the same and it's easy to do 15 take away 8. 15 take away is 7m, £14.10 minus £8.50, or you can just use a calculator for that. That gives you 5.6, which means dividing by 7, m is 0.8. Let's call this one equation 1 at the top. We're going to substitute that into equation 1 to find our a. So sub into 1. So let's just remind ourselves of the equation. We've got 4m, so it's 4 times 0.8 plus 3a equals 4.25. That gives you 3.2 plus 3a is 4.25. So taking away 3.2, 3a is 1.05, and dividing, of course, by the 3, we get a equals 0.35. Not answered the question yet though. We need to say a mango and an apple equals. So a mango equals £0.80. Or 80 pence, and an apple equals £0.35 or 35 pence.
Okay, National 5 Maths 2017 Paper 1 question 13 was a picture, but it gave you the two equations as well. It says the graph shows two straight lines with these equations. The lines intersect at point P. Find algebraic coordinates of point P. If it mentions point of intersection, that means solving simultaneous equations. That's a key thing to realise. So I just need to solve both of these equations simultaneously. So if I look at my two equations, I've got 3x minus y and x plus 3y. So I could times one of these by 3 to make the x's the same, or times this one by 3 to make the y's the same. This time I'm going to make the y's the same. So just times in this one by 3. I can write down the new equations I get. So the first one I'm going to get is 9x minus 3y equals 6. So I can write that, 9x minus 3y equals 6. And the second equation is staying the same, x plus 3y equals 19. So I'll call that equation 1 and equation 2. And this time you can see that these numbers are the same, but they're different signs. So I add the equations when they're different signs. So I do 1 plus 2. So 9x plus 1x is 10x. The y's disappear. 19 plus 6 is 25. So x is 25 over 10. Leave that as a simplified fraction if you want, or a decimal, because it's an easy decimal. I would write 2.5 for this one. Okay, and then we need to substitute in to get our y. So just pick a simple equation. I'm just going to pick x plus 3y equals 19 because there's only one x there. So I've got 2.5 plus 3y equals 19. So 3y equals 19 minus 2 is 17, minus 0.5 is 16.5. And just checking, this was a paper 1 question, yep. So I need to divide through by 3. 3 5s are 15, leaving 1. 3 5s are 15 again, 5.5. So we've now got our two numbers, 2.5 and 5.5, but it's to find the point, the coordinates of P. So I need to change that to a coordinate, an x and a y. So our final answer is 2.5 and 5.5. And we're done there. SQA National Maths 2024, paper 1, question 12. Express x squared minus 6x plus a in the form x minus a squared plus b. So completing the square, this is called. I always half the middle term, x minus 3 squared then, and you immediately take away 3 squared. And then you've still got plus 8 on the end. So that's x minus 3 squared minus 9 plus 8. And that gives me x minus 3 all squared. And minus 9 and 8 is minus 1. Part B, hence I state the coordinates of the turning point of the graph of y equals x squared minus 6x plus 8. So it's the same one. The turning point is given to you from the completing the square. Opposite sign of this, because that means you want 0 here in this whole bracket. So 3 minus 3 is 0, so that's 3. And then same sign, so minus 1. And that's it. Part C, the diagram shows the graph of y equals x squared minus 6x at 8. A line PQ has been drawn parallel to the x-axis. P lies on the y-axis, there. And P and Q lie on the graph of y equals x squared minus 6x plus 8, so there. Find the coordinates of Q. Well, I need to know where we cut the y-axis. So we cut the y-axis when x equals 0. So subbing that in, we get y equals 0 squared minus 6 times 0 plus 8. So y equals 8. So that means that this line is y equals 8. It's a horizontal line, so that's its equation. So I know what y equals 8. So I can now just say that we've got x squared minus 6x plus 8 must equal 8, because it's simultaneous equations again, but in a simple way, because it's a point of intersection. So taking the 8 over, we get x squared minus 6x, 8 minus 8 is 0, so we get nothing. X bracket x minus 6 equals 0. So that means we get x equals 0 and x equals 6. So the coordinates of Q finally, Q equals 6 along and 8 high, 6, 8. And we're done there. Okay, completing the square in the quadratic formula. SQA National Maths 2018, paper 1, question 19. Quite a big one this. Part A, express x squared minus 6x minus 18 in the form x minus p squared plus q minus p squared plus q or minus a squared plus b, completing the square. Then state the axis of symmetry, which we'll get to, and the roots of this can be expressed in this form. Find algebraic D and E. So this is a quadratic formula question in a paper 1. We've expressly put it like that because that's what it looks like at the end or before you've got your answer. So let's go through this step by step. Question A. I've got x squared minus 6x minus 81. So to complete the square, I go like 1 bracket squared, x minus half the middle term is 3. Now, how do I get my numbers on the end? Well, I immediately take off that number squared. So the number is take away 3 squared, technically minus 3 squared. Then you're going to still take away 81 because that's hanging around on the end. So that gives me x minus 3 squared. 3 3s are 9, so it's take away 9, take away 81. Because I'm over by 9 basically. So that gives me x minus 3 squared minus 9 minus 81. That's minus 90. And we're done there. Part B, 10 state the equation of the axis of symmetry. When you complete the square, we don't do it for nothing. It tells us something. It tells us the turning point. The turning point is this number here and this number here. That sign changes. So if it's minus, it becomes positive. Positive becomes minus because you're making this bracket 0. So my turning point is 3 minus 90. I'll just write that down. My turning point, which we may ask you in some questions, is 3 minus 90. When you draw a quadratic, it is symmetrical at the turning point. So when they ask you for the axis of symmetry, we're just asking you for x equals 3 because it's a vertical line, so x equals the number. Where does 3 come from? The turning point. So that's all we're asking you there. Part B says, the roots of the equation x squared minus 6x minus 81 equals 0 can be expressed in the form x equals d plus or minus d root e. Find the values of d and e. There's two ways to actually do this. You can start from completed square form, or you can go back and use the quadratic formula. I think most people will use the quadratic formula rather than the completed square form, so I'm going to do it that way. But just be aware you can do it the other way. So let's start off with x squared minus 6x minus 81 equals 0. If we look at the start of the exam paper, it says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So our a equals 1, the number in front of x squared, our b equals minus 6, and our c equals minus 81. X equals minus 6, watch there's a minus and a minus there, plus or minus the square root of minus 6 squared minus 4 times 1 times minus 81 all over 2 times 1. So watching out for minuses. Minus 6 is positive 6, plus or minus the square root of 6 times 6 is 36, minus times a minus is a plus. 4 times 81, well, you might need to do that sum at the side, but if you have to, just do this. 4 ones is 4, 4 eights is 32. So that, and it's a minus times a minus, so it's a plus. So it's plus 324. 2 times 1 is 2. We have to get it down to d plus or minus d root e. So x equals 6 plus or minus the square root of 324 plus 36. So that's 324, 330, 360 over 2. Well, 360 is like a surd, yeah? You may not know if it's an exact square root, but we can work it out as a surd because we can do root 360. 2 numbers at times together to make that, well, 36 and 10. So that means you get root 36 is 6, root 10. Now, root 10 can't be simplified further, so I can change my root 360 to 6 root 10. So x equals plus or minus 6, plus or minus the square root of 6, root 10 over 2. So that means that x equals, dividing the first thing by 2, I get 3, and the second thing by 2, I also get 3 root 10. And we're done there.
SQA National 5 Maths 2023, Paper 1, Question 4. The graph shows part of a parabola in the form y equals x plus a squared plus b. Now we're completing the square. State the value of a and state the value of b. So from the turning point, remember, if it's in completed square form, if I write this out, it would be y equals, so you've got x, and the sign changes for a. So it's 3 here, so it's minus 3. But for b, it stays the same, so it's plus 2. So if I had it like that, our turning point would be 3, 2, which is what it is. So a is minus 3, and b is 2. It now says P is a point 0C. Find the value of P. Well, 0C means it lies on the y-axis, as you can see here. So we're looking for a point of intersection with the y-axis. The easiest way to do it from completed square form is you square this number and then add that number. So we've got minus 3 squared is 9 plus 2, which equals 11. So C
Like the square of parabolas, SQA National Maths 2017, paper 1, question 14. The graph shows a parabola with the equation of the form x plus a squared plus b. That's called completing the square, remember. The equation of the axis of the symmetry of the parabola is x equals minus 5, as shown. State the value of a. So this is testing. Do you know that this tells you that? It does. It tells you the turning point. The a is the 5. So all we're asking you to do is write a equals 5, not minus 5. Because it's what makes this bracket 0. So it's 5 here. So it's minus 5 plus 5 is 0. So it's just 5. So A equals 5. It now says the point 3 minus 8 lies on the parabola. Calculate the value of B. So we've got x now equals, y equals, x plus 5 squared plus some number B. But we know the point lies on, so we're going to substitute the point in because that's an x value and that's a y value. So a is our y equals minus 3 is our x plus 5 squared plus b. So a equals minus 3 plus 5 is 2 squared plus b. 2 squared is 4 plus b. It should be clear that b must then equal 4 because 4 plus 4 is 8. If it now asked us what the turning point was, we would also know the turning point, it would be 5, 4, because that's exactly what completing the square does. SQA National Maths 2014, paper 1, question 7 on quadratic graphs. The diagram shows the part of the graph y equals ax squared, and it gives us a point. We have to find the value of a. So whenever you've got a point on anything, you need to realise a point is an x and a y. So if I write this is x and this is y, well, I've got an equation with an x and a y and an unknown, so I can just substitute in to find my answer. So y equals ax squared is what I'm starting with, but x equals minus 3 and y equals 45. So we're just subbing the values in. So 45 equals a times minus 3 all squared. 45 then equals a times minus 3 times minus 3 is 9. So that means I can say that 45 equals 9a, divided by 9, 5 equals a, or a equals 5 then. And we're done there. SQA National 5 Maths 2019, paper 1, question 9, completing the square. The graph shows a parabola of the maximum turning point is 420. Write down the equation of the axis of symmetry. So the axis of symmetry, remember, is this line that goes down the middle. That's a vertical line, so that occurs at x equal to 4 because the coordinate is 420. So remember, the turning point tells you how to find this in completed square form. So the completed square form is the turning point. A is minus 4 because it's the opposite to make that 0. So A equals minus 4 because minus 4 plus 4 is 0. And B is just your 20, the other number. So it's minus 4 and 20. SQA National 5 Maths 2015, paper 1, question 7 on quadratic graphs. The graph below shows part of a parabola with equation y equals x plus a squared plus b, so in completed square form. The minimum turning point 2 minus 4 is shown. Find the values of a and b. So let's do a little bit of work outside. Remember, the turning point can be given to you from completed square form. If I've got y equals x plus a squared plus b, then the turning point, remember, is equal to minus a b. The sign changes on the a, but the b stays the same. So I'm just putting 2 minus 4 back in. So I've got 2 minus 4 is my turning point. So that is minus a equals 2, and b is minus 4. So that means that a is equal to minus 2, because minus a is 2. In other words, it's y equals x minus 2 squared minus 4. Turning point here is 2 minus 4, which is what we have got. So writing the answer in the right place, I've got minus 2 for A, and B is equal to minus 4. Write down the equation of the axis of symmetry of the graph. So the axis of symmetry is the point, the line that goes straight down here. Well, that happens at 2. So the axis of symmetry is just x equal to 2, and we're done there.
Question 13 says, sketch a graph of y equals x plus 1x minus 3 using the axes provided below. And on our sketch, we need to show the points of intersection with the x-axis and y-axis and the turning points. So notice this is already factorised. So our roots are given straight away, x plus 1. So we've got x equals minus 1 and x minus 3. So we've got x equals positive 3. So we can immediately put that on, minus 1, and I'll make my 3 sit here, where it cuts the y-axis. So for the y-axis, we need to make, remember, x equal to 0. So we've got 0 plus 1, which is 1. I'll write it out actually. And 0 minus 3. So that's 1 times minus 3, which is minus 3. So again, on my y-axis, I can go down and say minus 3. I now just need my turning point. So my turning point is in the middle of the roots. So middle of minus 1 plus 3 is this, add them and divide by 2. 3 minus 1 is 2 over 2. It happens at x equal to 1. So at x equal to 1, y equals, substitute it back into our equation, 1 plus 1, 1 minus 3. That equals 2 times minus 2, which is minus 4. So our point is 1 minus 4. So we can note that. Let's go along to 1. Let's note minus 4. So it's about here. Make a nice neat sketch. Remember, it's going to be a parabola. So we go down here, through our axis, round and back up, and that will do. And I'll, just to be on the safe side, I'll note that that point is 1 minus 4. And we're done.
Okay, completing the square and parabolas. SQA National Maths 2016, paper 1, question 10. Sketch the graph of y equals x minus 3 squared plus 1. Show clearly the coordinates of the turning point and intersection of the y-axis. Well, the turning point is easy. TP, turning point. It is simply the opposite of this number, which is 3, the opposite sign, and then the second number 1. Why is it the opposite? Because it's what makes this 0. 3 take away 3 is nothing. Okay, where it cuts the y-axis. Cuts the y-axis when the other letter x equals 0. So just subbing that in, we get y equals 0 minus 3 squared plus 1. That's minus 3 squared plus 1. 9 plus 1 is 10. So the point is 0, 10. Or you can remember that you just do that squared plus that, always when it's in complete square form, to get where it cuts the y-axis. So now we can just draw a little picture. An x and y-axis, it's just a little sketch. So we're going to cut at 10, so I'll just note that. And our turning point is 3, 1. So we can go 3, along 3, up 1, say, is there. And then just draw a nice, neat parabola and label that point nice and neatly 3, 1. And we're done there. Mr. Clare here for Clare Maths. This one was from 2019 paper 1 National 5 Maths, and it was asking a question about a ball getting kicked off a cliff, and it asked us when will the ball hit the sea. Bit of a strange one, that one. So let's have a look at this one and see how we solve that one. Again, it's an unfamiliar context, so that is what makes it difficult. So here's a picture of the actual question. It says a ball is kicked from a cliff top and its height is given by this equation. H is 12t minus 5t squared. Part A, calculate the height of the ball above the cliff top after 2 seconds. Have a look and see if you can solve that. Then part B, continued, the graph below represents the height of the ball relative to the cliff top after t seconds. It says the sea is 17 meters above the cliff top. After how many seconds will the ball hit the sea? Have a look, see if you can solve that. Okay, the solution to the first problem. Calculate the height of the ball after 2 seconds. Well, we've got an equation. The height is 12t minus 5t squared, and they want t equal to 2 because it's 2 seconds. So it's just a substitution question in an unfamiliar context. So the height would be 12 times 2 minus 5 times 2 squared. That's 24 minus 4 5s is 20. So that gives me an answer of 4 meters for 1 mark there. Okay, part B,
This gives us the graph relative to the cliff top after t seconds. The sea is 70 meters below. After how many seconds will the ball hit the sea? Well, just remember our equation for the height was equal to 12t minus 5t squared. But we know that this must equal minus 17 because it's going down by 17 from the start. So that means we just need to say that that equaled 17 minus 17 for 1 mark. And that's difficult to see if you're not sure of the context of the question. Part 2 then says once we've got our equation, we just need to solve that equation in the normal way. So this is a quadratic. So if I move everything to the right-hand side, I'll get 0 on this side. I'll get 5t squared minus 12t minus 17. Or in the more familiar way, 5t squared minus 12t minus 17 equals 0. So that's a quadratic that we can now solve. There are two main ways to solve a quadratic. We can use the quadratic formula or we can factorise. Now, since this is a non-calculator paper, chances are that this will factorise. I'm going to show you my method for factorising at this point, see how you can follow along. So what I do, if I use a different coloured pen, if I times 5 and 17 together, 5 times 17, well, that equals 5 sevens is 35, 5 ones is 5, so that means 85. I'm looking for factors of 85, okay? There's not many options, but we need to add or take away to make 12. So let me start listing them in order. I've got 1 and 85. Well, they don't add or take away to make 12, the middle number. 2 clearly doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. The next one it goes into it is 5, because it ends in 5. 5 and 8 goes 1. 3 left over. 5 sevens is 35. Now, if you look and stop here for a moment, you should realise that 5 and 17 times together to make the 85 that I've just found out, but they add or take away to make minus 12. So remember, now we're just trying to make minus 12. So to make minus 12 is our key number. That equals minus 17 plus 5. So if we draw a box at this point, we have got 5t squared. And then we're splitting up our middle term into minus 17t plus 5t. That gives us my minus 12t. And then at the end, I've still got my minus 17. So now we can just factorise each line and column. So factorising this, 5t squared and minus 17t. The only common factor is t. But going up and down the way, the common factor between 5t squared and 5t is clearly 5t. Now it's like a Sudoku puzzle. T times minus 17 is minus 17t, so it's minus 17. And 5t times 1 is 5t, so it's plus 1. My factors have dropped out. So in the end, after all that work or any method you prefer for factorising, you get 5t minus 17, and you get t plus 1, and that equals 0. And if you can get to that part, you can get a mark there. Final thing to do is to solve that and work out your t's. So for the first one, you've got, from this one, you've got 5t minus 17 equals 0. That means that t must be 17 over 5 seconds. And then the other one, you've got t plus 1 equals 0, so t must be minus 1 seconds. But time is positive. So t minus 1 is invalid. So there is our final solution. 17 over 5 seconds is the one we're selecting as our final answer.
Mr. Clellan here from Clellan Maths. So another hard question that we're going to look at this time from a National 5 paper. It was a 2016 paper 2 question 12. So a good few years ago, but quite a common type of question to come up. And it says, the diagrams below show a rectangle and triangle. All measurements are in centimetres. Find an expression for the area of a rectangle for 1 mark. Then, given the area of a rectangle equals the area of a triangle, show that x squared minus 2x minus 8 equals 0 for 3 marks. Then find algebraically the length and breadth of a rectangle for 3 marks as well. Have a look at this and see if you can get anywhere with it before we come back and discuss it and see what the solution is. Okay, so what this question is asked us to do is find an expression for the area of a rectangle, which we'll do in a moment, but essentially it turns into a quadratic question, but also it is going to be, you're going to have to find the expression for the triangle, make them equal to each other, and then rearrange that equation to get that quadratic. Quite a hard skill. Once you've done that, you'll then have to solve your quadratic equation. I'm going to go through a few steps with this and a few pointers that I think might make this a little bit easier, especially if you can't do the whole question. Okay, part A, find an expression for the area of a rectangle. Don't be scared by this. You all know the area of a rectangle is length times breadth. So just write down what the length of the rectangle is. If it was a number, you would write down 4, 5, 6, but in this case, it's x plus 8. So I'll just write down x plus 8. Now, since this is going to be times by something else, I'll put that in brackets. And I need to times by the breadth for the height, which is 2x plus 1. 2x plus 1. So there is an expression for the area of my rectangle for 1 mark. Part B, given that the area of a rectangle equals the area of a triangle, show that this. Now, we'll try to get there, but we don't know how to get there. But it does say area of rectangle equal area of triangle. So we know the area of a rectangle is x plus 8 and 2x plus 1. And that equals the area of a triangle, where a triangle is half times the base, 2x plus 5, times the height, 3x. So we can write they equal to each other. So now we need to expand some brackets, and we'll get marks for expanding the brackets if I've managed to write this down. So expanding the left-hand side, I usually use a box. We get x plus 8 on one side and 2x plus 1 on the other side to get 2x squared plus 16x plus 1x plus 8. And that equals a half times 2 is 1. So that's 3x times 1 times x plus 5. So essentially it's a half times 2 is 1. Leaving just this to expand. That gives me 3x squared plus 15x. Tidying up the left-hand side, we get 2x squared plus 17x plus 8. And that equals the right-hand side of 3x squared plus 15x. You would get a mark for expanding this bracket and a mark for expanding that bracket. And then a mark for making them equal to each other and then somehow getting it down to the expression that they want. Now, the expression they want is equal to 0, so I need to move everything over to the same side. So I've got small 2x squared, so if I look at the right-hand side, I've got 3x squared plus 15x. I'm going to make this 0. I'm going to take away 2x squared then. I'm going to take away 17x, and I'm going to take away 8. So 0 equals 3x squared minus 2x squared, which is x squared. 15x minus 17x is minus 2x, and I've got minus 8. Or to put it in the way they want, x squared minus 2x minus 8 equals 0. Now, you couldn't get very far with this question if you couldn't do part A. And if you could even do part A, but you couldn't write down an expression for the triangle, or just didn't know what to do, you couldn't do part B. That doesn't stop you doing part C though, because part C then says, hence find algebraic with length and breadth of the rectangle. And the question already told you that x squared minus 2x minus 8 equals 0 in part B. So even if you've lost the first two parts, you can still, if you know how to factorize and find out x, work out this from using quadratics. Okay, so you either got a quadratic formula or you've got factorising. Now, since this is non-calculator, you can bet 9 times out of 10 we're going to factorise. So let's have a look at it. We have got x squared minus 8x, 2x minus 8 equals 0. You're looking for, just to factorise this, numbers that times together to make 8. So I've got 1 and 8 or 2 and 4. And I want to pick the pair that add or take away to make minus 2. Well, 1 and 8 never does it, so it's going to have to be 2 and 4. And then I just write down, how does that make minus 2? Well, it makes minus 2 by doing, it's not going to be 4 take away 2 because that's plus 2. It's going to be 2 take away 4. Or plus 2 take away 4 is minus 2. And plus 2 times minus 4, just to check, is minus 8, which is the last number. So I can now factorise it. And a lot of this you could have done without any working. X and X. I've got plus 2 in one bracket and minus 4 in the other. You get a mark for factorising. And then for solving, you can then say x plus 2 equals 0 or x minus 4 equals 0. So that gives me that x equals minus 2 or x equals 4 for a second mark. And then, because this is a question in context and we're talking about actual lengths of the triangle and rectangle, if we go back up and look at the lengths, we've got x add 8 on the rectangle. Well, that means that we've got 4 plus 8 and we've got minus 2 add 8. And then on the other side, we've got 2x add 1. So that's 2 times 4 is 8 plus 1 is 9. But then you'd have, if you use the minus 1, minus 2 plus 1. Minus 2 times 2 is minus 4 plus 1, which is minus 5. So we can't have a negative x because it's going to give us a negative height or breadth, and that doesn't work. We can't have a negative length. So we'll have to pick the one that's going to work. So using x equal to 4, the length is equal to, so remember back at our triangle, eight plus 4, which is 12 centimetres. The breadth was 2x add 1, so 2 times 4 plus 1, which is 9 centimetres. And we get our final mark for working that out. It's been Claire Maths today. We've looked at another hard National 5 Maths question, this time from 2016 paper 1. Hopefully that was helpful for you. Take care, stay safe, and goodbye.
Maths 2024 paper 2 question 8. Solve the equation 3x squared plus 8x plus 1 equals 0. Give your answer correct to 2 decimal places. Well, this is a quadratic, so I use a quadratic equation, quadratic formula, sorry, because it says give your answer to 2 decimal places. So start of the exam paper says that x equals minus b plus or minus the square root b squared minus 4ac over 2a. So in this case, a is 3 because it's the number in front of x squared, b is 8, it's the number in front of x, and c is 1. So x equals minus 8. Make sure you put this in right. Square root 8 squared minus 4 times 3 times 1 all over 2a, 2 times 3. So that is minus 8 plus or minus. You usually get a mark for working this bit out. So I'll work this bit out. 8 squared minus, I'll put a bracket, 4 times 3 times 1 is 52. 2 3s is 6. So that gives me minus 8 plus root 52 over 6, or minus 8 minus root 52 over 6. So I'll work them out separately. Minus 8 plus root 52 over 6 is always going rounded first, minus 0.131, which to 2 decimal places is minus 0.13. So there's my first answer. Second answer, minus 8 minus root 52 all over 6, or x equals minus 2.535, or a bunch of other numbers, but to 2 decimal places, that's minus 2.54. And we're done there. SQA National 5 Maths 2019 paper 2 question 6. Solve the equation 3x squared plus 9x minus 2 equals 0 to 1 decimal place. Right, it's a quadratic. It's asking me to 1 decimal place, so it's a quadratic formula. So I go to the front of the page and write down the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is the number in front of x squared, which is 3. b is the number in front of x, which is 9, and c is minus 2. So I need to sub this in carefully. That's minus 9 plus or minus the square root of 9 squared minus 4 times 3 times minus 2 all over 2 times a, 2 times 3. So you get a mark for substitution usually, then a mark for working out the bit under the square root sign, which is called a discriminant. So I'll work it out next. Minus 9 plus or minus the square root of, well, 9 squared is 81. Well, let's use a calculator, shall we? So we've got 9 squared minus, I'll open a bracket, 4 times 3 times minus 2. That's 105. All over 2 times 3, which is 6. So now we've got two answers, x equals minus 9 plus root 105 over 6, or x equals minus 9 minus root 105 over 6. So let's do them both separately with a calculator. Brackets for the top, minus 9 plus root 105. Close the bracket, divide it by 6. That gives me 0.207a. I'll just put dot dot dot, and then the other one, brackets, minus 9 minus root 105 over 6 is minus 3.207 with a bunch of other numbers. And we'll round that to one decimal place, so then that gives me 0.2 or minus 3.2. Always show your unrounded answers first before you round.
SQA National 5 Maths 2023 Paper 2, Question 14. A storage unit is built in the shape of a cuboid as shown. It has a length of x plus 7, a breadth of x, and a height of 2, and the volume is 45. We have to show that 2x squared plus 14x minus 45 equals 0. Relatively standard question this by now. We can write an expression for the volume and make it equal to 45. So the volume of a cuboid, length times breadth times height. So let's just write that down. We've got x times x plus 7 times 2, and that equals 45. So expanding the brackets, well, we've got 2x times x plus 7, I suppose, equals 45. 2x times x is 2x squared. 2x times 7 is 14x, and that equals 45. Or taking the 45 to the other side, we get 2x squared plus 14x minus 45 equals 0. And we're done there. Part B, calculate x, the breadth of the storage unit, give your answer to one decimal place. So the hint here is it's a quadratic. One decimal place means we're using the quadratic formula. So from the start of the exam paper, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, my a is equal to 2, my b is equal to 14, and my c is equal to negative 45. So we get x equals minus 14 plus or minus the square root of 14 squared minus 4 times 2 times 45, what's a minus 45, all over 2 times 2. That means that x equals minus 14 plus or minus the square root of, you get your calculator out and work out 14 squared minus 4 times 2 times minus 45. You've got 196 for 14 squared. 4 times 45 is 180 times 2 is 360. Minus times a minus is a plus. So it's plus 360 all over 2 times 2, which is 4. So we get x equals minus 14 plus or minus the square root of 556 over 4. So we get a calculator out for x equals minus 14 plus 556 over 4. And x equals minus 14 minus root 556 over 4. So using our calculator, for the first one, bracket minus 14 plus the square root of 556, all divided by 4 is 2.39, dot dot dot, but to one decimal place, 2.4. And then for the other one, we've got minus 14 minus root 556 divided by 4. We've got x equals minus 9.39. And I'm not even going to round that one because this is a round for breadth, so that isn't the one we're going to use because you can't have a negative length. So therefore our only answer is 2.4 metres and we're done there.
SQA National Maths 2015, paper 2, question 14 on quadratics. A rectangular piece, picture measuring 9 by 13 is placed on a rectangular piece of card. The area of the card is 270 and there's an X border all the way around the sides. To write down an expression for the length of the card. Now don't worry about this question, I've still got to solve a quadratic for parts B, which is worth 4 marks. So if you can't do the first 2 parts, still just skip ahead to part B. Okay. Right, part A, calculate the length. So for part A, 1, well, our length is, we can just trace this out, x plus 13 plus another x. So that's 2 x's plus 13. Part 2, hence show that 4x squared plus 44x minus 153 equals 0. It doesn't seem to tell you much, but it's basically we're going to use the area because the area of the card is 270. So I write down what the area is. It's this length times the breadth. So our area equals 2x plus 13 times. Now we've got 9 plus another 2x, so 2x plus 9. And we know that that equals a total area of 270. So we can expand and simplify. So expand on the left, 2x and 13, 2x and 9. That still equals 270. And we've got 2 times 2 is 4x squared. 9 times 2 is 18x. 2 times 13 is 26x. And 9 times 13, use a calculator if you have to, you get 117. So that's 4x squared. 26 plus 18 is 44. X plus 117 equals 270. The rest is equal to 0, so I'll take away 270. So that's minus 153. So we get 4x squared plus 44x minus 153 equals 0, which is exactly what we have got. So we're done there. Part B is a big bit. Calculate x, the width of the border. It says give your answer correct to 1 decimal place. So we've got a quadratic with x in it, and it equals 0, so we can just solve that quadratic. But since we have to make it to 1 decimal place, it's not going to factorise, so we're going to go to start of exam paper and use the quadratic formula. If you go to start exam paper, you would find that x is equal to minus b, plus or minus the square root of b squared minus 4ac, all over 2a. Now, a is 4, b is 44, and c is minus 153, so we'll just substitute in. So we've got minus 44 plus or minus the square root of 44 squared minus 4 times minus 153 all over 2a, 2 times 4. So being very careful with substitution, watching for double minuses. We've got minus 44 plus or minus the square root. Use our calculator for that bit. So 44 squared minus, open brackets, I'll usually think about brackets being around here, 4 times minus 153, close the brackets, 4384. All over 2 times 4 is 8. That gives me 2 answers, remember. X equals minus 44 plus the square root of 4384 over 8. Or x equals minus 44 minus the square root of 4384 over 8. So working out our 2 answers. Minus 44 plus the square root of 4384 equals this. Press equals, press divide by 8. And we get 2.776. Always write down unrounded answers first, which is to 1 decimal place, 2.8. So now we'll do our other one. You can use brackets for this as well. Minus 44 minus the square root of 2384. Sorry, 4384. Close the brackets, press divide by 8, press equals. This one equals minus 13.776. So to one decimal place, minus 13.8. We've got two answers, but we have to calculate x, the width of the card. So this is a question in context. It can't have a negative length or negative width. So we can just disregard this one by crossing it out and say that x equals 2.8. Is it in any units? Centimeters. Centimeters. And we're done there. So make sure you correct the correct one and make it very, very clear that that's the one you want. For normal quadratic equations, you'll have two answers, but for this one, just one you need to pick because you can't have negative length. And we're done there.
SQA National 5 Maths 2023, Paper 1, Question 5. Determine the nature of the roots of the function 4x squared plus 6x minus 11. SQA National 5 Maths 2023, Paper 1, Question 5. Determine the nature of the roots of the function 4x squared plus 6x minus 1. So that is using the determinant. The determinant is in the quadratic formula, b squared minus 4ac. So I'm going to look at b squared minus 4ac. So a equals 4, the number in front of x squared, b is 6, and c is negative 1. So that means I've got 6 squared minus 4 times 4 times minus 1, 36. And then you've got 4 times 4 is 16, times 1 is 16, minus times a minus is a plus, so plus 16. 36 plus 16 is 52. And then we need to make a statement. Now the statements are if it's positive, negative, or 0. So since this is positive, since b squared minus 4ac is greater than 0, there are two real, you need to use the word real, and distinct roots. Or two real and different roots.
Using the discriminant, SQA National 5 Maths 2018, Paper 1, Question 8. Determine the nature of the roots of the function f of x equals 2x squared plus 4x plus 5. If it mentions nature of the roots, you're using the discriminant, which you'll get from the start of the exam paper. If you look at the quadratic formula, the bit under the square root sign is b squared minus 4ac. That's called the discriminant. So our a is 2, our b is 4, and our c is 5. Signs are important. So b squared is 4 squared minus 4 times 2 times 5. That's 16. 4 2s are 8, 5s are 40. 16 minus 40 is negative 24. And then we need to write a little statement. And the statement is always since b squared minus 4ac, this one is less than 0, there are no real roots. There are two options when you do this. If you get 0, there are two equal roots and two real equal roots. And if you get a positive number, there are two distinct real roots, two different real roots. Okay, right, there we go.
SQA National 5 Maths 2023, Paper 2, Question 3. The diagram shows part of a football pitch. The penalty spot is marked at C. AB is an arc of a circle, radius 9.5. Calculate the length of the arc length. So arc length is just angle, 106 degrees out of 360 degrees, times by pi times by diameter. So diameter, well, the radius is 9.15, so the diameter is 9.15 times 2, which is 18.3. So times 18.3. That gives me a total of 16.9279 meters, or you could round it to just 16.9 meters, I suppose. And we're done there.
On arc length, 2022 National 5 Maths Paper 2, Question 10. An attraction at a theme park has a carriage attached to an arm as shown in this picture.
The arm swings from A to B along an arc of a circle centre C, as shown below. The length of the arm is 15 metres, and the length of the arc is 69.4. Calculate the size of the reflex angle ACB, in other words, this angle here. So it's just arc length because it's length of arc. So I'll just write down what I know. Arc length equals angle over 360 times pi times diameter. Substitute everything in. So my arc length is 69.4. That equals my angle, which I don't know, over 360 times pi times 30, because 2/15 is 30. And you'll get a mark for substituting in. If we need to rearrange it in the same way we've been doing. So I start off with, to get my angle, 69.4. Divide by everything that was on top, pi times 30. Times by everything that was on bottom, 360. So then we can just work that out in a calculator by doing 69.4 times 360 divided by brackets pi times 30, and you will get an answer of 265.08 or 265 degrees, and that is 3 marks. So on arc length, we've got SQA National 5 Maths 2015 Paper 2 Question 10 had this question: the pendulum of a clock swings along an arc of a circle with centre O. So you've got 65 degrees here. The pendulum swings through 65 degrees. The length of the arc is 28.4. Calculate the length of the pendulum. So we're working backwards from arc length, but it mentions length of arc, so we can substitute in. So writing down arc length, again, equals angle over 360 times pi times diameter. When we substitute everything in we've got, so it's told us the arc length is 28.4, so I can write 28.4 equals our angle, which is 65, over 360 times pi, but I don't know the diameter, so I can just write times diameter. Now I find the easiest way to work back here is you could either try and rearrange it directly, or what I like to think of is, usually I do divide by 360 and times by everything else. So for going backwards, I'll do the opposite, which means I'll times by 360 and divide by everything else. So I can immediately write down that D equals, starting with 28.4 for the left-hand side, I'm going to divide that by, well, everything on the top that's normally times. So 65 times pi is going to go in the bottom. Then the thing that's usually divided is 360, so I'm going to times the top by 360. And I get my D straight away that way. And then I just go to a calculator and work that out. So I just do 28.4 times 360 and then divide by 65 times pi. I can use brackets around the top and brackets around the bottom. And if you do that, you will get an answer for D, which is 50.07 centimetres. Now, we'd usually be finished here for calculating the diameter, but it asks us to find the length of the arc, the length of the pendulum. Well, if that was to go all the way around, it would be a circle, and that would be a radius. So the length of the pendulum is half that. So our length is equal to 50.07 divided by 2, which to a reasonable degree of accuracy is 25 centimetres. SQA National 5 Maths 2016 Paper 1 Question 3 for area of a sector. The diagram shows a sector of a circle, centre C, and the radius is 20, the angle is 45. Calculate the area of a sector without a calculator. So we'll start off with the same way. Area equals angle out of 360 times pi r squared, and we calculate that by putting 45 out of 360 times pi times 20 squared. 2 marks so far, 1 mark for getting the fraction and 1 mark for substituting in, and now we just need to do lots of work to get the actual answer for our final mark. So fractions, we simplify. So 45 into 360, well, 45 goes into 360 8 times, so I get 1/8 times pi. 20 times 20 is 400, so I do an 8 for 400 is 50 times pi,
And then again, you can just at the side do 3.14 times 5. 5 fours is 20. 5 ones is 5 plus 2 is 7. 5 threes is 15. You get 15.70. So that gives you, that's times by 5, so it's 10 times 15.70, which is 157 centimetres squared for our final answer. Another quick way at this point will be to times by 100 and then divide by 2.
SQA National Maths 2024, Paper 2, Question 15. The diagram shows the sector of a circle, centre C. The radius is 12. The length of the arc is 15. Find the area. Well, that's a bit of a dodgy one. So to find the area of a sector, I need the angle. So I'm going to have to work backwards from the arc length. So let's call that theta or anything you want. Arc length, angle over 360, times pi, times the diameter, which is double 12, 24, equals the arc length, which is 15. So working backwards from there, I can immediately get theta, because I always do it this way. I've divided by 360, so I times this side by 360. 15 times 360, all divided by pi times 24, because that's on top. (15 times 360 divided by open brackets pi times 24 is 71.6 degrees. So there's my angle. So now I can work out the area, because the area is the angle out of 360 times pi times r squared, which is 12. There's other ways to do this, but this will be fine. 71.6 divided by 360 times pi times 12 squared is 89.975. And it's centimetres squared, or you can just round it if you want, but it would round up to about 90.0 centimetres squared, which I never like the look of, so I'd probably prefer just to unround it. Maths 2024, Paper 2, Question 7. A paperweight is in the shape of a cuboid. It consists of a hemisphere of red glass surrounded by clear glass. The cuboid is 4 centimetres with a square base of 7 by 7. And the hemisphere has a diameter of 6. Calculate the volume of the clear glass in the paperweight. So obviously the hemisphere takes up some space. So I need to do the whole volume minus the hemisphere. So I've got the volume of a cuboid. So the volume is going to be 7 times 7 times 4. Hopefully you can all do that. Minus the volume of a hemisphere. Well, check the start of the exam paper and you'll get 4/3 pi times r cubed. Now, let me just write that up here. That is a sphere. So the radius is equal to 3, because it's half of 6. So 4/3 times pi times 3 cubed. But I need to do a half of that, or divide by 2. So times a half or divide by 2, because it's a hemisphere. Now, most people work these out separately. So 7 times 7 times 4 is 196. Minus 4 divided by 3 times the pi button times 3 to the power of 3 is 113.097. Divide that by 2 or times it by a half is 56 point. Now, I wanted to do significant figures, so just a reasonable number here, 54866, blah, blah, blah. I never bother to round until at the end. 196 minus 56.54866. Now, it would have been 67 actually, but I've put ... so I'm safe there. So that gives me 139.451 and a bunch of other numbers. And I only need 2 significant figures, so I'm rounding here. That rounds up to 140. And the units are centimetres cubed. And there you are. There's your volume of the paperweight glass.
SQA National Maths 2023, Paper 2, Question 9. The concrete block is in the shape of a large pyramid with a small pyramid removed. The large pyramid has a square base of 90, as you can see. The small pyramid has a square base of length 40 and a height of 48. The whole block has a height of 60. Calculate the volume of the block. So, a big pyramid minus a small pyramid. So go to the start of the exam paper and check the formula for a pyramid. you will see that it is a third of the area of the base times the height. So the volume of a pyramid is a third times the area times the height. So our big pyramid we'll start off with, that's a third times. Now the large pyramid's got 90 on the bottom square base, so 90 times 90. And the height, 60 plus 48 is 108. So just get a calculator to work that out. 291,600 centimeters cubed, I suppose. And then the small one, that's going to be a third times 40 times 40 times the height of that pyramid, which is 48. That gives us a total of 25,600. Volume of the block is just a takeaway. 291,600 minus 25,600, 266,000 centimeters cubed.
Another volume question, SQA National 5 Maths 2018, paper 1, question 17 had this one. A square-based pyramid is shown in a diagram. The square has a base length of 6 and the volume is 138. Calculate the height. So this is a working backwards volume question. So math stages, there's a few ways you could do this, but math stages is always to write down my formula, then work backwards. So from the start of the exam paper, the volume of a pyramid is 1/3 times the area times the height. Okay, so substituting everything in, I've got 138 on this side equals 1/3 times, now it's a square, so it's 6 squared or 6 times 6. I'll just write 6 squared times the height. Stage we're going to do 138 equals a third of 36 times h. 138 equals, well, 3 into 36 goes 12, so that's just 12h. And then we can work out h. 138 divided by 12 is equal to 11.5 centimetres. And that is one of the simplest ways to work it out. You could have also just made h the subject of the formula and worked it out, but there you go. SQA National 5 Maths 2016, paper 2, question 7. A carton is in the shape of a large cone with a small cone removed. So it's a takeaway. The large cone has a diameter of 32 and a height of 24. The small's got a diameter of 18 and a height of 13.5. Calculate the volume of the carton, and again, rounding involved to two significant figures. So we do the volume of the big cone minus the volume of the small cone. So let's just do that, right? So the volume of our big cone is, remember, volume of a cone is 1/3 pi r squared times h. Given at the start of the exam paper, 1/3 times pi times, now the radius is going to be 16 because it's half the diameter, and the height is 24. So we get a mark for doing that and getting an answer. The answer to that would be 6433.98 with a bunch of other numbers, centimetres cubed. Now we do the small cone. The volume of the small cone, 1/3 times pi times the radius, which is 9, half of 18, squared, and times the height of the small cone, which is 13.5. We put all that in our calculator and we get 1145.11 and a bunch of other numbers, centimetres cubed. So we've got one answer, two answers for 2 marks. And then we get a mark for knowing that we need to take away. So our volume is equal to 6433.98 minus 1145.11. And that gives us, using the unrounded figures to take away, 5288.87. And then we get, for rounding our final mark, 2 significant figures it says. So that equals 5300 units, centimetres cubed, for 5 marks.
SQA National 5 Maths 2024, Paper 2, Question 10. Karen buys a door sign for her house. It's two identical circles with the numbers 2 and 7 in it. AB is a chord of both circles, a line, in other words. And it has a length of 15, and the radius is 10. Find the width. Well, let's have a trace out of this. If that was the centre here, I already know that bit's 10. I already know from here to here's 10. So I really just need this bit. Oh, wait a minute. I just made a right angle triangle. How cool is that? So let's do that. Right angle triangle. Identifying that as the key part. I've got 10 here. And this was 15, but if I cut that there, that's cutting it in half. So that is 7.5. Now, Pythagoras says that a squared plus b squared equals c squared. And that is a, b, and c is the longest side. So I've already got the long sides, I'll take away. So I do 10 squared minus 7.5 squared. And then I'm going to square root my answer. So I'm going to do that in one go. Because I've got a calculator. 10 squared minus 7.5 squared in brackets square rooted is 6.614. Round is not really that important, but let's just make that 6.6 centimetres. Because everything else is two significant figures, so why not? So now we can work out our length, because we've got here to here is 10. Another centre there is also 10. And I've got double 6.6. Let's just double check when I double that, it rounds to the same thing. Yeah, 13.2. So that's fine. 6.6 times 2. And this length here now is 13.2. So I just do 13.2 plus 10 plus 10. That's 13, 23, 33.2 centimetres. I'll double check on that because it was a longer question. That's definitely 10. That's definitely 10. And that's definitely 2 of them. So I'm frankly happy with that.
SQA National 5 Maths 2023, Paper 1, Question 10. Alan buys some identical pavement slabs to make a path. Each slab is part of a circle. The diagram below shows a single slab. There's a number of information. The radius is 50. The length AB, which is a straight line, is 60. Calculate the width. Now this might be hard to work out what's going on here because it doesn't look like a standard one of these questions because of this curve. But ignoring that for a moment, we've got some sort of part of a circle and you've got a straight line and a straight line. So I can make a triangle hopefully somewhere, and it's going to be a right angle triangle problem. So it's Pythagoras in circles. So I have to calculate the width of the pavement slab. So the width goes from here out to here. There's the whole width. So if I knew this line, that's the radius. If I added on this bit, I would be fine. So I get my pen and just make a triangle. That's a right angle. A radius cuts a chord at right angles in half. So my right angle triangle, taking it out of the thing, I've got 50 centimetres here, and half of 60 is 30. So if I call that, say, A, then A squared is 50 squared minus 30 squared. Don't be worried about squaring 50, just square 5, and then times it by 100 or 2 zeros. 50, 5 fives is 25, so that's 2,500. 3 threes is 9, so that's 900. That gives you 1,600. So A is the square root of 1,600, which is 40, because 4 fours is 16. And therefore our width is just 40 plus, well, we've got now a radius from up to here. The radius we know is 50. So it's 40 plus 50, which is 90, and the units are centimetres. And we're done there. A train tunnel has a circular cross section with a horizontal floor, and here's the diagram below. Calculate the height of the tunnel. Clearly, to me, it clearly is a Pythagoras question. It's asking me for the whole height. Well, I know the radius from here to here, but I don't know this bit. So if I fill in that bit first, if I just draw a line down, make a right angle, then we've got 2 here and 2.9. So we can do I'll call this x. X squared is going to be 2.9 squared minus 2 squared. That gives me 4.41.
So x is the square root of 4.41, which is exactly 2.1. So I now know that that's 2.1 using Pythagoras, and then we've got this extra bit here, but that extra bit there will be 2.9 because it's a radius. So our total height just equals 2.9 plus 2.1, which is exactly 5 metres. SQA National 5 Maths 2019, Paper 2, Question 18 had this question. It's a cartoon snowman, and it's got a lot of information about the head is a small circle with centre S, and the diameter of that from here to here or here to here is 15. The large circle has got a centre of T, and it also lies on the circumference of this one, and A and B lie on the circumference of both circles. Calculate the height of the snowman. Looks quite difficult, but if we notice, we know this line here is 15, so we're really just being asked to calculate the radius of the big circle. Now we could calculate it anywhere. So if I go inside this bit from here to the outside, that's a radius of the big circle too. I'll draw that in. And we already know of some facts. We know that'll make a right angle, but we know that the diameter of the small circle is 15, so that is 7.5, but so is this. So taking that outside of the circle, just to be clear, we have got 7.5 here and 7.5 here with a little x here. So x squared is 7.5 squared plus 7.5 squared. So that means that x equals the square root of 7.5 squared plus 7.5 squared, which we can calculate and then square root or just use brackets to get about 10.6. So that means now that our height is just, well, let's just double check. It's going to be the diameter to T, which is 15, plus the radius of the big circle, which we've just worked out is 10.6. That gives you 25.6 centimetres.
Beam is used to support a wall on a horizontal ground, as shown in the diagram. The edge of the beam is 8 metres long, C is at the foot of the wall, A is 7, B is 4 metres from C. Determine whether the wall is perpendicular to the ground. The word perpendicular means at right angles, so we're just doing Pythagoras, the converse of Pythagoras. So what we need to check is, does 7 squared plus 4 squared equal 8 squared? So let's just keep it separate because we're checking. So let's do 7 squared plus 4 squared on this side, and let's do 8 squared on that side. So in a calculator, 7 squared plus 4 squared is equal to 65, but 8 squared is equal to 64. So since 7 squared plus 4 squared does not equal 8 squared, then by the converse of Pythagoras, or just by Pythagoras, not a right angle, triangle, and then to make the context of the question, therefore, or right therefore, the wall is not perpendicular to the ground.
SQA National 5 Maths 2017 Paper 2 Question 7 had this one, and it says triangles A and B are shown and are put together to form a big triangle. Is it a right angle triangle? Well, we're going to have to identify our three sides first of all. So looking here, that's 8 centimetres there. 8 centimetres. And on the other side, we have got this one, which is a part of the big B, 19 centimetres. And then on the bottom, we're joined together, so it's 16 and 6 to make 22 centimetres. So keeping it all separate, our left-hand side and our right-hand side, we've got 8 squared plus 19 squared, or we've got 22 squared. Working both of them out separately, 8 squared plus 19 squared is 425. And 22 squared is 484. A mark for getting 18 squared, 19 squared and 22 squared. A mark for working both of them out. And then for saying something. So the something is 8 squared plus 19 squared does not equal 22 squared. Therefore, not a right-angled triangle. You could write by the converse of Pythagoras, but there's no real reason to mention it, but you could say that. SQA National 5 Maths 2022 Paper 2 Question 11, another 3D Pythagoras question, and it's telling us that the length of the cuboid is 24, the breadth is 6, so there's my length and breadth, and the height is 8. Calculate the space diagonal from front to back, so it's just 3D Pythagoras. 24 squared plus 6 squared, the base, times the height, 8 squared. So I can write 24 squared plus 6 squared plus 8 squared all in one go. And then we can work out that by doing the square root of all of that. So we can do the square root all in one go, just put brackets around the sum, and you will get 26 centimetres. Moving on to 3D Pythagoras. SQA National 5 Maths 2018 Paper 2 Question 16. So this is often calculating a missing length in a 3D shape, usually with a space diagonal. Chris wants to store his umbrella in a locker. The locker is a cuboid with internal dimensions 40, 40 and 70. The umbrella is 85 metres long. He thinks it will fit in the locker from P to M. Is he correct? You should probably just put that umbrella in the locker and check himself, but let's do some maths. So we've got 40 by 40 by 70, and we want to calculate the space diagonal. So we're going to go from here, the front to the back. All you need to know is that you can do 40 squared plus 40 squared, and that will give you the diagonal of this, and then you use the diagonal of this with the height to get this, or all in one go, you can just write 40 squared plus 40 squared plus 70 squared. So that is our strategy. So whenever you're doing a space diagonal, it is the base numbers times the height, all squared, 3D. So then we need to square root that to get our answer. So it's 40 squared plus 40 squared plus 70 squared, all square rooted. If you do that, you get 90. And then just a little statement, his umbrella is 85, we got 90, so yes, because 85 centimetres is less than 90 centimetres. Done.
SQA National 5 Maths 2024 Paper 1 Question 10. The diagram below shows a circle centre O. AC is the tangent to the circle at B, there it's there, and CE is the tangent at D, there it's there, and BG and DF are diameters. Angle DEFE is 125. Find the shaded angle, which is way down at the bottom. So let's start off with our rules. Tangent meets a radius at right angles. We've got angles on a straight line, and then the main other one is two radiuses make a isosceles triangle. So if we can get into here, then we can maybe get this angle, which means we can maybe get that angle. And then we need to work out these somehow and then get that angle. So let's just start from there. So I'm going to do 180 minus 125. So 25, 35, 45, 55, 65, 75 makes 55. So I now know that this one up here is 55. But because that's a radius and that's a radius, this one down here is also 55. So I can now do two 55s as 110. 180 minus 110 is 70. So I get 70 in the middle straight away, basically. And a little rule you should know is if two lines cross, vertically opposite angles are equal. So the ones that are opposite each other are equal, so that gives me 70 here. And angles round a point add up to 360. So I've got 140 already. So if I do 360 minus 140, that will give me what's left between these two. And they're the same size that you can see. We'll check that in a minute, but I'm pretty sure they are. So that is 0, that is 2, and that is 2. So divide by 2, I get 110 here and 110 there. Let's just double check they are the same, and I can do that by doing this. Next rule, tangent meets a radius at right angles. So let's point our right angles in. There's one, there's one. This will be a right angle there, and we've got one here. And since that is a right angle, then this triangle here gives me 20 up there. Now, if that's 20 up there, then that means that we're good to go. So let's look at a big triangle. You probably don't have to do this in the exam, by the way. It's just to double check for this. 70, 90, 20. Yeah, so I've got all the angles. But you can go straight ahead from your 110, and now you know that this is 90 here and 90 here. I have got a four-sided shape. And four-sided shapes, angles add up to 360. So I've already got 90 and 90 is 180. So that means that these two opposite add up to 180. So I get my 70 down here, and I'm done there. Now, big note on this one. If you just get 70 here and let your answer is 70 without any more working, you won't get the answer because you have to show where that 70 comes from. Okay, although there's 70, you have to show where that 70 comes from. And that's that done.
National 5 Maths 2022 Paper 1 Question 4 had this diagram, and we have to calculate the size of ACE. So that goes from here to here to here. But as usual, I'll just start with the angle I'm given and work up to it. So I've got 68 here. So is this an isosceles triangle? Yes, it is. So I can do 180 minus 68. That is 120 minus 8, 112. So 112 divided by 2. 2 into 11 goes 5, 56. So we get 56 down this side. Now we can move on to our next triangle. Over here, angles on a straight line add up to 180. So 180 minus 68 is 112. And again, you should be able to see that that's an isosceles triangle on this side as well. So you can do 180 minus 112 to get 68, and then divide that by 2 to get 34. So you get 34 degrees up here. Tangent meets radius at right angles. So I now know that there's a right angle on this side, but also on the other side. So these two add up to 90. So I do 90 minus 34 to get 80, 70, 60, 56. And then identifying it, what we want me to go from here, A to C to E. So that is this angle inside here. So we didn't actually need that 56, we just need to know that was 90. 90 plus 34 is 124. So our angle is 124 degrees for our final mark. So we get a mark for getting 112 or for getting 56. We also get a mark for getting the 34, then a mark for adding 34 to 90 to get 120.
Question 5. The logo consists of a H shape and a regular decagon, 10 sides, decade. The diagram represents the logo. Calculate the size of a shaded angle, which goes from here to here in this diagram, okay? So, well, the first part's easy, that's a right angle. But the next part, we need to calculate the size in here. So, let's start dealing with this decagon. We need to know these angles really. So a decagon is a 10-sided shape. So in the middle, if I do 360 divided by 10, I get 36 degrees. So I now know that this bit in here is 36. And these are isosceles triangles, so I can work out each of these angles here by doing 180 minus 36. That's 144. 144 divided by 2 then is 72. So each of these angles on the outside is 72. I need to know how far it is from here to here. Well, I don't know this angle, but I know that all the way down this point will be 360. 90, 180, so, or that angles on a straight line out to 180. Minus 72 minus 72, or minus 2 lots of 72, 36 again. So I now know that this little one in here is 36. And therefore, the size of the shaded angle is equal to 90 plus 36, which is 126 degrees, and we're done there.
SQA National Maths 2024, paper 1, question 14. In the diagram, triangles ABC and ADE are similar. So they're similar, so I've got ABC, let's just do that, and that is 3 centimetres here. And then it says ADE, the big one, ADE, well, we've got 10.5 here, and then we've got 7 on the bottom. So hopefully you can see that since they're similar and this side is this side, I can do the scale factor and I can then find the length here. So I'm just going to go ahead and do that. So the scale factor is equal to 3 over 7. So that means this length here, x, is 3/7 of 10.5. So that is equal to 3 tens are 30. Well, 3 5s is 15, carry 1. 3 tens are 30 plus 1 is 31. 0.5 over 7. 31.5 divided by 7. Well, 7 4s is 28. 29, 30, 31. 7 5s is 35. So that gives me 4.5. So I now know that this bit here is 4.5. And it asks me to calculate BD, which is this bit here. So that means I need to do 10.5 minus 4.5. So BD 10.5 minus 4.5. 4.5, 5, 6, 7, 8, 9, 10.5 is 6. And the units are centimetres. SQA National Maths 2017, paper 1, question 15 on similarity. In the diagram below, TS is parallel to QR, TS is 5, QR is 7, SR is 2.6. Find the length of PS is X, calculate the length of X. So this is similarity because we've got parallel lines and making triangles. So we've got one big triangle and one little triangle. So I can draw them out separately to illustrate this. For the small triangle, that goes like this. I'll put the little arrow on it. That's 5 by x. And then for the big triangle, we'll just draw it a little bit bigger so you can see, that is 7. And usually, and then the bottom length is x plus 2.6. So if we think of our linear scale factor, if we just think of a big triangle to little triangle, the large scale factor, it's 7 over 5. Same side over same side. But it's also this side over that side. So I can see that that equals x plus 2.6 over x. I've now got an algebraic equation to solve, so I'll just go ahead and solve it. And with two fractions, you can just do top times bottom. 7x equals top times bottom, so I'll just put brackets around that. 5x plus 2.6. Expanding my brackets, 7x equals 5x. 5 2s are 10, 5 6s are 13, so that's plus 13. That means that 2x equals 13, so that x is equal to 6.5 centimetres. And the question was, find the value of x. That's me done. Happy days. SQA National Maths 2016, paper 2, question 11 on similarity. Two pictures are mathematically similar in shape. The cost is proportional to the area. The large picture costs $13.75. Find the cost of the small picture. So it says cost is proportional to area, so I need to find the area scale factor. So starting with the linear scale factor, I have to find the smaller picture. So I start with the small side over the big side. So the linear scale factor is 60 over 100. Simplify that to 6 over 10, which is 3/5. So that means that my area scale factor is simply my linear scale factor squared. That's 9 over 25. And remember, this is a paper 2 question, so it could be calculator you use. So then that means that our cost is simply 9/25 of £13.75. So I'll just get my calculator and work that out. 9 divided by 25 times £13.75 is £4.95. And we're done there. SQA National Maths 2019, paper 2, question 13 on sector area and similarity. It says in the diagram, the sector ABC is a sector of a circle with a centre C, and DEF is a sector of a circle with a centre F. the sectors are mathematically similar. Says the area of the larger sector is 2750. Find the area of the small sector. So we're using area scale factor. So we need to find the linear scale factor first and then find the area scale factor. So we have to do the smaller one. So we start with the smaller side, 30 over the big side, 50. So our linear scale factor is 30 over 50. Or you can simplify that to 3/5 if you want, which means our area scale factor, remember, is we'll just square that scale factor. 3/5 squared. Calculator paper, so you can just do 3 3s is 9, 5 5s is 25 in the calculator. So now to get the area of the smaller sector, we just take our scale factor and times by the area of the big sector, which is 2750. Now this is a calculator paper, so let's just do that. 9 divided by 25 times 2750 is 990. 990 centimetres squared. And we're done there. He says calculate the size of angle ACB. So we're in the big sector, and we know that if we've got an angle, then angle over 360 times pi r squared, because we're doing sector area, equals the area. Well, the area I'm given is 2750 for the big sector. So we're just working backwards from there. So to get your theta, I find the easiest way to work backwards is start with your answer, which is 2750. And as you go back, every time something's on the bottom, that now turns up on the top. So times 360. And anything that was originally on the top for times in, we just divide by it. So we've times by pi r squared. So we divide by pi r squared. And R, remember, for the big sector is 50. Pi times 50 squared. And then we just get a calculator and work all that out. Now you can do it in one go in the calculator. You just bracket 2750 times 360 divided by bracket pi times 50 squared. Close your bracket and you get 126.05 or 126.1 degrees. And we're done there.
SQA National Maths for 18, paper 2, question 18 on similarity. A cinema sells popcorn in two different sized cartons. There they are shown. The small carton has 16 centimetres deep and has a volume of 576. The large is 24 centimetres deep and has a volume of 1125. Part A, show the cartons are not similar mathematically. So to show they're not similar, what we can do is find the scale factors if they were similar and work out what the volume of the large one should be, and you'll probably get a different answer. Well, you will get a different answer to what they've got as 1125 cubic centimetres. So let's start off. Part A, the linear scale factor, and I'm just going to go for the big one, is 24 over 16. Now we're using a calculator, so no need to simplify. Let's just go straight into the volume scale factor then. Remember, that's just 24 over 16 cubed. So if similar, then the volume of the big one will be equal to 24 over 16 cubed, the scale factor, times the volume of the small one, which is 576. So we'll just get a calculator and see what that answer is. So in my calculator, I use brackets for this, 24 over 16, close the bracket, press cubed, times 576. I get 1944 cubic centimetres. But the volume of the small is, the big is actually 1125. So I can write actual volume of big equals 1125 centimetres cubed. So not similar. Part B says, the large carton is redesigned so the two cartons are now mathematically similar. The volume of the large carton is 1500 cubic centimetres. Calculate the depth of the redesigned large carton. Okay, so we know that the new volume we're going to have to use is 1500 and the original is 576. So we can work out the volume scale factor, then working backwards from that, find the linear scale factor to find the new depth. So we're trying to find it in the large one, so it is large over small. So for part B, our volume scale factor is 1500 over 576. So that means that our linear scale factor is working backwards the cube root, because we normally cube to get the volume scale factor. 1500 over 576. So the depth of our big carton is equal to our scale factor, cube root of 1500 over 576, times the depth of our small carton, and the depth of our small carton has stayed at 16. So again, calculate a job for that. So I need a cube root, so shift square root on my calculator. Make sure you use brackets to do your fraction. 1500 divided by 576. Close the brackets. You can either press equals then times 16 or a little arrow to get out of the square root. Times 16, and I get 22.012. .848, blah, 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 centimetres. Or you can round that to a reasonable place, let's just say 22.01 centimetres or 22. Question doesn't ask us to round, so it's best just to write down your unrounded answer. And we're done there.
SQA National 5 Maths 2024, Paper 2, Question 14. The diagram shows a rhombus. ZW is vector A, ZX is B. Find WX in terms of A and B. I know a lot of people don't like these ones, but I'm just going to start here and I want to end there. So I'll just take a route I can see. Down here, minus A, along there, plus B. Minus A, plus B. And we're done. That's it. M is the midpoint of X, Y. Find W to M. So I need to go to W to M. So I need to start and I need to end there. Now I can't go down there, I don't know anything about that. But I can go this way and I can go along here and then I can go down there. Now what's special about this line is it's exactly the same as that line and it's in the same direction, so it is actually A. So let me just write that here then. I'm going to trace down there, along here, and down there. So what have I actually got? I've got minus A plus B, like I've already done. And then down here is just a half of here. And I'm going in the opposite direction, so it's minus a half A. Because I'm not going up the way, so it's not plus a half A. I'm going down the way, so it's minus a half A. So I'll write that in the question place. Minus A plus B minus a half A. Minus A plus B minus a half A. Simplifying that, minus 1 minus a half is minus 1 1/2, or minus 3 halves. Minus 3 halves A plus B, and we're done there. SQA National 5 Maths 2018 Paper 2 Question 10. Diagrams below, A to B and E to A represent vectors U and W. As you can see, U and W. It says that E to D is 2 lots of A to B. So this one is double that one. So that means I can immediately write down that this one here is 2U. It also tells me that E to A is 2 lots of C to D. So if E to A is double that one, that means that this one is half of this one. So I can immediately write down that this one is a half of W. It now says express B to C in terms of U and W. So I need to get from B to C. So I could go this way, B to C. But I can't actually, I don't know anything about that. But remember, vector roots means you can just go any direction you want. So I'm just going to start at B and go back all the way around and write up everything I've got. So B to C is equal to, starting at B, I need to go this way. That's minus U. Then this way, minus W. Then this way, plus 2U. Then this way, plus a half W. Simplifying everything else, the U's go together. Minus 1U plus 2U is just U. And then minus 1W plus a half W is minus a half W. And we're done there. We'll just put little underlines on it because they are vectors. SQA National 5 Maths 2019 Paper 1 Question 10. Some vectors here. It says in triangle PQR, PR is 6 minus 4 and RQ is minus 1 8. Express PQ in component form. So P to Q is going from here to here. That is the same as P to R plus R to Q. So writing that out, P to Q equals P to R plus R to Q. So that equals 6 minus 4 plus minus 1, 8. which is equal to 6 minus 1 is 5, minus 4 plus 8 is 4. 5, 4 in component form. Part B, M is the midpoint of PR, express M to Q in component form. So let's find a root for M to Q. We could go from M to P to Q or M to R to Q. Let's go that way. So M to R plus R to Q. So we could say that M to Q equals M to R plus R to Q. Now we already know what R to Q is, it's minus 1/8, so we need to find out what MR is. It should be obvious that M to R is a half of P to R. So we can write that down, that M to R equals a half of P to R, which equals a half of 6 minus 4. So just half in both the numbers, that's 3 minus 2. And therefore M to Q equals our 3 minus 2 plus our R to Q, which is minus 1/8, which equals 3 minus 1 is 2, minus 2 add 8 is 6. 2 to 6 is our final answer. SQA National 5 Maths 2024, Paper 1, Question 4. A is 3, 4 minus 1, B is 5, 3, 2. Find 3A plus B. Okay, so 3A plus B. So I need to times A by 3. 3 3s is 9. 3 4s is 12. 3 1s is 3, so it's minus 3. Plus B, which is 5, 3, 2. So being careful, 9 plus 5 is 14. 12 plus 3 is 15. And minus 3 plus 2 is minus 1. And we're done there. SQA National 5 Maths 2018, Paper 1, Question 4 on vectors. Two vectors are given by U is 1, 5, 1. U is 1, 5, 1. And U plus V is 6 minus 4, 3. So U is this one plus some V, which we don't know, equals 6 minus 4 and 3. So we're just working backwards. So if we're starting at the answer, 6, take away 1, we'll give you this one, 5. That means 5 plus 1 is 6. Minus 4, take away 5 is minus 9. Doing the opposite of plus. 5 minus 9 is minus 4, just a quick check. And then 3 take away 1 is 2, just a quick check. 2 plus 1 is 3. So we're done. Just to write our answer out at the side, V is 5 minus 9 and 2, and we're done there. SQA National 5 Maths 2019, Paper 2, Question 2. Find the magnitude of vector P. So magnitude is just like Pythagoras. I just square each number and square root them. 6 squared plus 27 squared plus minus 18 squared. Square root 6 squared plus 27 squared plus minus 18 squared is 33, and we're done there.
SQA National 5 Maths 2018, Paper 2, Question 3 on vectors and the magnitude of a vector. Find R, the magnitude of a vector, 24, minus 12, and 8. So magnitude of a vector, remember, just like Pythagoras, it is Pythagoras actually. So the magnitude of R is equal to the square root of 24 squared plus minus 12 squared plus 8 squared. Now this is a calculator job, so you get your calculator and we press square root, making sure we're using brackets, 24 squared plus bracket for a minus, minus 12 squared plus 8 squared equals 28. And we're done there.
By Maths 2019, Paper 2, Question 5. The diagram shows a cone with diameter 6 and 8. The x and y axis are tangents to the base. A is the point of contact with the base on the x-axis, and B is directly above the centre. Find A and B. So let's see where A is. We need to go from here to here. Well, that length is the diameter 6, so that length is 3. I can just take a note of that here. That goes along 3. I go along 3. I don't go in and I don't go up. So it's 3, 0, 0. So straight away, A equals 3, 0, 0. Let's find B. B, I need to go along 3. In 3, because again, diameter 6, and then I need to climb up the whole height. Now the height is 8, so it's 3, 3, 8. And I'm done there.
SQA National 5 Maths 2018, paper 1, question 13 on 3D coordinates. It shows us this picture. It tells us that A to D is equal to A to E. So in other words, this side is equal to that side. So we can take a note of that just by putting little dashes in, just to remind us later. It says that DC is equal to 8. So there's D to C, there is 8. And it says that we've got edges EF, DC, and AB parallel to the y-axis. Write down the coordinates of B and C. So let's work out how we get to B. Well, if we start at 0, 0, we always start, we need to go along, and that'll be in the middle of the shape, because if we see B here is in the middle here, so I need to go along to the middle of the shape, then down the y-axis, and then up high. So I just need to work out these 3 lines. So let me draw them in. I need to go along to here. Well, how far is that? I've went along 2, and then if you notice the difference between these coordinates is 2, so that means I went along another 2. So I went 2, 4. So I can write B equals 4. Let me just note that for you. I then went in this far. Well, we already know that this line here is 8, so it's the same again. That is 8 in. And then I need to go all the way up the shape. So we need to know how high that is. Well, let's check if there's any other coordinates that tell us that. If we look at A, 4, 0, 5, 5's the y-axis, so 5's the height there, so 5's the height there. So I can just say I'm going up 5, so I've got 4, 8, 5 for B. We can do the same for C, so let me use a different colour so you can really see that. So I need to work out how to get to C, so again I'm going along all the way to D, then I'm going all the way in to C, but then I'm not moving, so I already know that Z is going to be 0. So let's just work out along the way first. I need to jump all the way along here. So how far is that? Well, we already know that that goes 2. And then that goes another 2, that's 4. Symmetrical makes 5, 6. So that line there is 6. Then I go in this way, which we already know is 8. So we've got 6, 8. Then I don't move from that point, so 0. 6, 8, 0. Is my final answer.
SQA National 5 Maths 2022, paper 2, question 6 had this question. Calculate the area of this triangle. Again, it's exactly the same. There's my C, because that's the angle. So any other ones would be my A, opposites A, B, opposites B. Area is a half AB sine C. So that gives me 0.5 times 32 times 25 times the sine of 58 degrees. We get a mark for substitution, it's worth 2 marks, and then a mark for a final answer using a calculator. If we type 0.5 times 32 times 25 times the sine of 58, making sure we've got degrees, we get 339.21 square centimetres. 339 would be an acceptable answer, or 0.2 or 0.21. SQA National 5 Maths 2018, paper 2, question 17 says, in the diagram below, AOD is a sector of a circle with centre O, and BOC is a triangle. In the sector AOD, the radius is 30 centimetres and the angle is 75 degrees. So we've got AOD, we know that this bit here is 30 centimetres. And it also says in the triangle OBC, O to B is 38, so this whole bit's 38, so we know that we could put a wee 8 here, I suppose. And we know that O to C is 55, so we can draw that in there and say that that's 55 centimetres. What is it asking us? Well, it's asking us to calculate the area of a shaded region. So this is a combination of area of a sector, which is why it's in here, and area of a triangle, which is in the trigonometric section. So let's start off, we can do any one you want, but it's going to be a takeaway, because if I do the whole area of a triangle, I get all the area shaded in, but then I need to take away the area of the sector to get this shaded bit here. So it's a takeaway triangle minus sector. So let's do area of a triangle first. From the start of the exam paper, the area of a triangle is a half AB sine C. So that's 0.5 times, well, remember it's the angle and the two sides either side of the angle, So it's this side 38 and this side 55. 38 times 55 times the sine of 75 degrees. You put all that into your calculator and you get an answer of 1009.39. Bunch of other numbers, centimetres squared. So you've done your triangle, you get a mark for that. You now need to do your sector, so let's go back to our sector work. So we've got angle out of 360 times pi times r squared. So let's write that. Area of sector is our angle out of 360 times pi times, and we need to identify our radius, so let's go back up. The radius is just 30 centimetres, so it's 30 centimetres squared. So you get a mark there for identifying your fraction, and you get a mark for writing down fraction times pi times 30 squared. And if you work it out in a calculator, you get 589.04 centimetres squared. So far we have got 3 marks. There's 2 more marks. The next mark is for working out, you need to do the triangle minus the area and writing that down. So our shaded area is equal to our 1009.39 minus our 589.04. And we get a mark for just writing that down, and then a mark for our final answer, which is about 420.3 centimetres squared. And obviously I'm putting ... because I've not rounded, but 420 would be fine, or 420.3 centimetres squared would be fine as well. SQA National 5 Maths 2023 Paper 2 Question 15. AC is perpendicular to BC, AB is 18, BD is 6, BC is 8. The area of a triangle is 160. Calculate the length of AE. Area of a triangle. Right, let's start with that then. Area of a triangle is a half AB sine C. And by A and B we mean the 2 lines over the angle. Now, we don't know this angle, but we do know this length here, which is 18 plus 6. So we know the whole area, we know this length, and we have to calculate this length. So if we knew this angle, we'd be good to go, because we could just work backwards. Well, that angle's fine. Sine of this angle, let's call it theta. Sine theta is equal to the opposite, 8 over the hypotenuse 18, just from SOHCAHTOA and basic trig. So I can replace sine C with 8 over 18. So that means our area is equal to a half times this length, 18 and 6 is 24, times this length, which is A to E, I suppose we could call it. I'll just call that AE for clarity, times our sine of the angle in between, which is this one, which is 8 over 18. But remember, our area is 160. So a half of 24 is 12. So we've got 12 times 8 over 18 times E equals 160. So we can work on that. 12 times 8 is 96. So we get 96 over 18 times some side AE equals 160. So rearranging that then, AE must equal 18 times 160 divided by the top of 96. 18 times 160 divided by 96 is 30. So our length is 30 centimetres.
SQA National 5 Maths 2023 Paper 2 Question 4. The diagram shows triangle JKL. It tells you angle KJL is 25. JL's 10, KL's 7. Calculate the size of angle JKL. So JKL is up here. So it's this angle it wants. So it looks like this is the sine rule because you've got opposite, 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 opposite. So I can say, just remember from the start of the exam paper, A over sine A is B over sine B is C over sine C. So the information I've got is 7 over sine 25 equals opposites 10 over sine k. So we can do 7 times sine k is 10 times sine 25. So that means that sine k is 10 sine 25 over 7. So let's work that one out. 0.6037 4. So k is the inverse sine of my answer. Which is equal to 37.1 degrees. Or you'd probably find with just 37 because every numbers to two significant figures in the question.
24, paper 2, question 13. AC is 22, BAC is 40, then we've got 30, and when BD is perpendicular to AC, find the length of BD. So I've got triangles, so it's probably something to do with sine or cosine rule, and I need to find a length. Now, I can't really do much if I've got no lengths in this triangle and no lengths in this triangle. So I'm going to have to find a length. So I'm going to have to use a rule. So let's see if we can find out any angles first. 40 and 30 is 140 and 30 is 70. So that whole angle in here is 110. And now I've got opposites. So I can do that and that go together, and then any angle I want, either this one or this one, and the opposite side. And then I'll have a side. And once I've got that, I can just use SOHCAHTOA. Or the sine rule again, double sine rule, a lot of people use. I'll probably use SOHCAHTOA for speed. So we have got, start exam paper, A over sine A is B over sine B, is C over sine C. That's just to remind you, but it's just that I think about opposites. So I've got the whole length 22 over sine 110 equals, and I'm just going to find this one. So that is, I'll call it A because it's opposite A. Equals A over opposite sine 40. So we can rearrange that. A sine 110 equals 22 sine 40. So A is 22 sine 40 over sine 110. So we're getting a calculator. 22 sine 40 divided by sine 110 is 15.048. So 15.05 would be reasonable in centimetres. So now we know that this is 15.05. So you could either use the sine rule again in the right angle triangle or just SOHCAHTOA. Let me just draw that out. I've got this triangle here, and I've got 30 degrees down here, and I've got 15.05 here. And I'm trying to find the height, which I'll just call x. So you could just say I've got opposite over hypotenuse, which is sine. So sine 30 equals x over 15.05, or x equals sine 30 times 15.05. 15.05 times sine 30 is 7.525, or 7.5 centimetres. Or if you want to use the sine rule again, then you could say you've got, if I just do this at the side, x over sine 30 equals 15.05 over sine 90. And if you rearrange that, you get x sine 90 equals 15.05 sine 30, which means that x is 15.05 sine 30 over sine 90. But because sine 90 is 1, and if you use your calculator, you'll get the same answer of 7.5. And we're done there.
Simplify Maths 2019, Paper 2, Question 19 had this long question. So it says Katie and Mona are looking up at a hot air balloon. In the diagram below, K, M and B represent the positions of Katie, Mona and the balloon. So that'd be Katie, that'd be Mona, that'd be balloon. The angle of elevation of the balloon from Katie is 52, there it's shown there. The angle of elevation of the balloon from Mona is 34, there it's shown there, and the distance between Katie and Mona 350. And it says, calculate the height of the hot air balloon above the ground. It's quite a hard question, it's worth 5 marks. Notice, it's not asking me to calculate any of these diagonals, it wants me the direct height. So I can draw in a direct height here to show this, just by drawing a straight line down. And that's the side it wants me to calculate. Do not be tempted to think that cuts this line in half, it does not. So I'm going to need to get one of the other sides in order to use the sine rule or to use SOHCAHTOA to get the height. So that's exactly what I'm going to do. I'm going to start off by using the whole triangle to get one of the sides. You can pick any one you want, okay? I'm going to calculate this one, but you could go the other way and calculate this one. So let me draw a little diagram for us, or take some notes on this one. If I draw that without all the information, it's sometimes easy to do this. You've got 350 down here. I've got 34 degrees here, 52 degrees here, and I want to calculate this side here. I'll call that A. So I'll call that like A. So I've got this pair, and I'll need another pair, but I've not got this one. So the first thing I'm going to have to do is get this angle at the top, because I need it to go with this one. So adding these two numbers together and taking away from 180. So 52 plus 34, that gives us 86. 180 minus 86 is 94, so I can note that is 94 degrees and start my work. Got A over sine 34 equals 350 over sine 94. And if you're going this route, you will get a mark for that. We now need to rearrange that. So A sine 94 equals 350 sine 34. So A must equal 350 times the sine of 34 over the sine of 94. So getting a calculator and working that out, you get A is 196.195, or 196.2 would be fine, or even just 196. So far I've got 3 marks, substitution, rearranging and getting an answer. But now I need to get the height, okay? So redrawing my triangle to the side with all the information I've got now. I want this height here. I know that this bottom whole thing is 350. I've just calculated that this one is 196.2. And I know some angles. I know this is 52 degrees. This is 34 degrees. I'm not going to bother putting this on because it doesn't cut it in half. It adds up to 94, but it doesn't cut it in half. You can calculate either this angle or this angle using right angle triangles here. But there's lots of ways now to work out this height. The easiest way is to use the sine rule again. So we'll go ahead and do that. We have got, if I use a different colour, I'm going to use this one, goes with this one. And we're going to use this one, this is an angle B, goes with this one here. So we can just simply write A over sine 52 equals 196.2 over the sine of 90, because that's 90 degrees. Rearranging that, that implies that A times the sine of 90 equals 196.2 times the sine of 52. So A equals 196.2 times the sine of 52 divided by the sine of 90, which is 1, by the way. Just a note on this question, once you get to this point, that is a right angle triangle. You could have just used SOHCAHTOA to find A. I basically didn't, but I've just not bothered to do it for this question because SOHCAHTOA is a National 4 skill, but you might have forgotten, you don't need it at all in National 5. You can just keep using the sine rule, just use the sine rule twice and realise that this angle is 90 and you'll be good.
SQA National 5 Maths 2023, Paper 1, Question 6. AC is 5 metres, BC is 6 metres, cos C is a fifth. Calculate the length of AB. So this is one of those questions where we're using the cosine rule, but we're giving you the cos of the angle, so you can just go straight away. So let's remind ourselves of the cosine rule. Let's start with the exam paper. The cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. Now that's just a generic a, b and c, remember, so you can either relabel your sides to get your a, b and c where you want it, or just remember that the side A is the one opposite the angle you're given, which is cos C. So I'm going to do it that way. I'll just call that my A, and I'll just call that my B and C, and therefore that's my little a there. So I can say that my a squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cos of A, which is cos of C, because that was originally C, remember, so that's a fifth. And now we can start working on that. A squared equals 25 plus 6 sixes is 36. 2 fives is 10. 10 sixes is 60. A fifth of 60 is 12. So minus 12. So A squared is 36, 46, 56. 61 minus 12 is 59, 49. And therefore A is the square root of 49, which is just 7 meters. And then just to answer the question then, it says calculate the length of AB. Length of AB equals 7 meters. And that's just to be on the safe side because I've relabeled the sides, but you'll probably be fine if you didn't do that.
SQA National Maths 2017 Paper 2 Question 3 had this question. It says PQ is 250, PR is 180, and this is the angle, and it's building a fence around this. We only wish to build a fence alongside QR. What is the length of the fence? So we need to work out the length of QR. So once again, just checking, as long as I've got the angle in the sides, either side of the angle, I can use that to cosine rule to find the opposite side. So I'm going to label this side my A. We could even call that angle A if you want, just for the sake of it. And then that would be my side B and that would be my side C. Doesn't really matter which is which. So we write down the cosine rule from the start of the exam paper. We'll always go back and check it. B squared plus C squared minus 2BC cos A. Substituting in 250 squared plus 180 squared minus 2 times 250 times 180 times the cos of 147 degrees. Remember, we can do that in one step in a calculator. Put brackets around this, minus brackets around the whole of this, and you will be fine to go. And if you do that, or you take your time on it, you get 170,380. 0.3, and that's A squared, remember though. So that's just got 2 marks so far, substituting and getting A squared. So now just calculate our A. The square root of 170,380.3, and you get an answer of 412.77 meters.
24 paper 2 question 3. AB, AC and BC is in a triangle, 25, 18, 34. Find the size of a shaded angle. So I've got 3 sides of a triangle. So I say 3 sides means the cosine rule. So you go back to the start of the exam paper and copy the cosine rule for an angle, which is cos A equals B squared plus C squared minus A squared over 2BC. Cos A equals B squared plus C squared minus A squared over 2BC. SQA have been quite happy here that we're giving you A and that's A, so that's B and C. But I don't really care about the letters usually. In between is your B and C, and the angle's in between. So it's 18 squared plus 25 squared minus 34 squared over 2 times 18 times 25. Usually work out my top and bottom separately. 18 squared plus 25 squared minus 34 squared is minus 207 all over 2 times 18 times 25, which is 900. So that's cos A. So I do the inverse cos. I usually just keep it as positive and use a cast diagram. But we'll see what happens if you did it negative. You'll probably be okay. But I'm going to always do it that way because it's the right way to do it. Inverse cos 207 over 900 is 76.7 degrees. So now I need to find my angle by using a cast. Cos is negative, so it's not A and C, it's S and T. So that means that my answer for A is 180 minus 76.7. Which is 103.3. So we get 103.3 degrees, and we're done there. Now, let's just check what would happen if you'd done shift cos and done minus 207 over 900. Happily, we give you it as 103.3, so you're done there. Now, I never do that. I always use the cast diagram when cos is negative, so I'm consistent with all my working. But there we are.
9. The diagram shows a triangle ABC. Calculate the value of cos B. Cos B? Trig. Start of the exam paper. Let's go. All the way back. It says the cosine rule. Cos A is b squared plus c squared minus a squared over 2bc. Let me just write that down and copy it down for this question. So we're way down at question 9. So usually the cosine rule is written as cos A equals b squared plus c squared minus a squared over 2bc. And it was to work at the value of cos B, which is here. So I'm just going to call that A, just to make that the one I want. And that means the opposite side is A, and the other two sides are B and C. It doesn't matter which is which, so I'll just call that B and that C and just substitute. As long as I make my angle A, I'm fine. So we've got cos A equals 7 squared plus 3 squared minus 5 squared over 2 times 7 times 3, 49 plus 9 minus 25, 2 7s is 14, 3 14s, 28, 38, 42. So that gives me 49 plus 9, which is 58, minus 20, which is 38, minus 5, which is 33, over 42. Is that simplified? Well, numbers that go into both of them, I can divide by 3 to get 11 over 14. Now, we've written cos A, remember, but that's actually cos B. So our final answer, to be very clear for the examiner, cos B is 11 over 14. That's my answer. I want to change it to cos A and change the letters to make it make more sense to me because we're using cos A as the formula. Okay, last one, 2018, paper 2, question 13. Hopefully you're getting the hang of this by now. A ferry and trawler receive a request for help from a stranded yacht. On the diagram, E, F, T and blah. On the diagram, the points F, T and Y show the positions of the ferry, the trawler and the yacht. Ferry, trawler, yacht. It tells us lots of information in the bullet points. Just check that it's actually already in the diagram. So it says Fy is 7.2 kilometres, it is. Ty is 5.6, it is. Ft is 10.3, it is. And it says that F is on a bearing of 240 degrees from T. 240 degrees from T to F. Good. It says calculate the bearing of the yacht from the trawler. A little bit of a different question. This is asking us to calculate a bearing this time, not an angle. So the bearing of the yacht from the trawler. So that means it's asking us really, starting at the trawler, go north, turn all the way around, past here, up to here, so I'm facing the yacht. That's what it's asking me to calculate. Don't worry too much if you're not quite sure what it's asking you to calculate, just start off in the same way. Although in this case, as soon as you see three sides of a triangle, you should be thinking cosine rule to get an angle. So it's really just identifying which angle it's asking for. So once more time, calculate the bait of the yacht from the trawler, all the way around to the yacht. So I'm going to need this angle here. So let's just note this angle here. That's the one I'm looking for here. Cos A is equal to b squared plus c squared minus a squared over 2bc. So quite often, again, you'll probably just want to mark your angle as angle A so that you can substitute properly, or I'll always remember really that the one I'm taking away is opposite the angle and the other two are the ones that are adding. But let's just mark it A. So for clarity, so if I call that A, that is little a, and then the other two is going to be B and C, our sides. So we can then say we've got 5.6 squared plus 10.3 squared minus the 7.2 squared all over 2 times 5.6 times 10.3. That's cos A. You'll get a mark at that point for substituting correctly into the cosine rule. So there's a mark right there.
So for our next mark, if we can work out either that cos A is equal to, well, it's 85.61 on the top over 115.36, or leaving that as a decimal, which would be something like 0.742, that gives us our second mark. Then looking at our third mark, calculating the angle. So A is the inverse cos of 85.61 over 115.36, or the inverse cos of this. And that gives me an angle of 42.008. 088, sorry. So there's our third mark, and then our fourth mark is for calculating the bearing. So just to remind you, the bearing is 240 plus this 42. So we can do 240 plus 42 is 282 degrees for our final mark.
2017, paper 2, question 10. In the diagram below, D, E and F represent the positions of Dunbridge, Aylesford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Aylesford, and it's drawn it in for us. From Dunbridge, the bearing of Fairtown is 126, which is drawn not to here, all the way round, north, down to Fairtown. From Aylesford, the bearing of Fairtown is 230. From Aylesford, 230 to Fairtown. Calculate the distance between Dunbridge and Fairtown. Calculate this distance. Let's just mark that up there with an X. No other information given. So again, the strategy is the same as before. We're trying to find angles inside the triangle, so we can use the sine rule or the cosine rule. Let's just start on this bit here. You've got north and east. That's clearly a right angle, so I can write 90 degrees. And then angles around a point add up to 360. So I can do 230 plus 90, which is 320, giving me 360 minus 320, which is 40 degrees. I can put 40 degrees inside this triangle there. On the other side, since it goes northeast, this bit also right here is 90 degrees. So that means these two add up to 126. So doing 126 minus 90, I get 36 degrees. So I've now got a second angle inside the triangle. Once I've got two angles inside the triangle, I may as well just find the third one, because chances are I'm going to have to use it. 36 plus 40, so let's just write that. 36 plus 40 is 76 degrees. 180 minus 76, because angles in a triangle add up to 180, gives us 104 degrees. So we can write that down here. And now we can check what it's asking us. To find a missing side, we've got one other missing side.
So it's the sine rule, because for the cosine rule you would need this and this to get this. You've only got one side, so it must be the sine rule. So it's x over sine 40, opposites, x over sine 40 equals, and then the other side we've got is 15, and the opposite is 104. 15 over sine 104. A nice way to do this in your exam is to maybe get a different colour and just draw a line. These go together and these go together. Obviously they would go together as well, the other two, but I can't use them because I don't need that. So marks so far. You're getting a mark for 40 and 104 degrees. If you've managed to so far just calculate your angles inside your triangle, over here you've got a mark, and then you've got a mark for writing down the correct sine rule. Now we need to rearrange it. So as per usual, we can say that x sine 104 equals 15 sine 40. So x is still 15 sine 40, but then divided by the sine of 104 degrees. And that's a mark at that point as well. And then our final mark, of course, just for working that out in a calculator, 15 times sine 40, then divided by sine 104, you get an answer of 9.936. Or if you're rounding, 9.9 would be fine, and the units are still kilometres. Try not to forget your units. In National 5, there's one question where they will mark the units. They won't take marks off for forgetting the units in all questions, but there's one question you can never tell which one it's going to be, so just make sure you do your units. 2014, paper 2, question 10 was, in a race, boats sail around the three buoys, A, B and C in the diagram below. B is 8 kilometres on a bearing of 60 degrees. C is 11 kilometres from B. A is 13 kilometres from C. And the first part of the question is calculate the angle ABC. So they've given us a diagram in this case, so we can just get started straight away. A to B to C. It's this angle in here. So just take a little note of that. That's this one. And if we just check, if we're given three sides of a triangle, and we can always calculate an angle using the cosine rule if we already know all three sides. If we have opposite pairs, an angle on a side, and then maybe a side, and we're trying to find the missing angle, that would be the sine rule. So in this case, it's the cosine rule. So a reminder from the start of the exam paper. So cos A equals B squared plus C squared minus A squared over 2BC. Now, there's a couple of ways to think of this. When they say cos A, they mean the angle you're looking for, we're calling A. But in this case, there's a B attached to this, so don't get too confused. It is always, the angle, the one you take away, is always opposite it. So 13 is my A here. If you want to avoid confusion, you can draw yourself a little diagram, like so, and go, right, I'll call that A because that's the angle I want, and then my 13 is my little a. Then the other two sides would be B and C, so that would be B at 11 and C would be the other side, which is 8 kilometres. So we can say that the cos of our angle equals 8 squared plus 11 squared minus 13 squared over 2 times 8 times 11. And you would get a mark at that point for substituting in. And then we need to work this out. So cos A would equal, using a calculator, you would do 8 squared plus 11 squared minus 13 squared, get an answer, then divide by 2 times 8 times 11, making sure you're using brackets, and you would get 0.09. With a bunch of other numbers. So then to get an angle, we need to do the inverse cos. So the inverse cos of 0.09 equals 85 or 84.8. So 85 degrees would be a reasonable degree of accuracy. Or if you've got 84.8, that would be fine. So just to answer the question, remember they said angle ABC. I would then write, to be very clear, angle ABC equals 85 degrees. And we're done there. So now for part B says, hence find the size of a shaded angle. Well, we've already worked out that now this is 85 degrees. And it says find the size of this angle here. So we're going to use some angle rules. We know from the previous example that I did before that if you've got two north lines, the angles inside those north lines add up to 180. So I can immediately just diagram do 120 there, because 120 plus 6 is 180. And our second rule, we often use angles round a point add up to 360. So we can do a bit of work and say 120 plus 85 degrees is equal to 205 degrees. So we get 360 minus 205, which just gives us an answer of 155. Obviously, if you kept your answer as 84.8 for part A, then you would write 155.2 instead. 1 mark for working out what you need to take away from 360, and the final mark for calculating it, of course.
SQA National 5 Maths 2024 Paper 1 Question 8. The graph of y equals a cos bx is shown. Find the value of a and b. Okay, so for a, I check the amplitude, it goes to 7 and minus 7, so it literally is just 7. And then for b, I'm seeing how many waves there are up to 360. Well, that's 1, that's 2, so it's just 2. And what?
SQA National 5 Maths 2023 Paper 1 Question 13. Part of the graph of cos x plus a degrees plus b is shown. State the value of a, state the value of b. So our standard cos graph, remember, just to remind you, goes like this, and it's between 1 and minus 1, 90, 180, 270, and then right at the end, 360. Not a great picture there, but you get the idea. So the amplitude is between 1 and minus 1. So the amplitude stayed the same, but it's added a number. It's went from 1, and its maximum value is now 2. So b is simply 1. And for the state the value of a, it's a shift to the right or the left. So looking at this turning point here, we can see that the turning point usually happens at 180, but it's shifted by this amount. Well, what's that amount? Well, it's going up 1, 2, 3, so it's going up in 30, 90, 30, 60, 90, so 180, 210. It's shifted to the right by 30 degrees. A shift to the right means a negative number, so a equals minus 30 degrees, and b is equal to just 1. So that's the graph of cos of x minus 30 plus 1.
SQA National 5 2015 Paper 1 Question 9 on trig graphs. Write the following in order of size, starting with the smallest. We've got cos 90, cos 100, and cos 300. So we need to kind of justify our answer here. There's two ways you could do this. You could use a cast diagram, or you can draw a graph. I think drawing a graph is the easiest way. So I'll show you both ways anyway. Drawing a graph. So I'm just trying to sketch a cos graph. So that's a cos graph that you should all know. And it goes to 1 and minus 1. And then it goes 90, 180 at a turning point, 270 here, and 360 at the end. So that's our x and that's our y. So now just kind of noting on this graph where roughly 90, 100, and 300 is. I'll use a different colour. So there's 90. I'll call that 190. Using a different colour for 100. Well, 100 is at past 90, so we could say 100 is about there. And then for our last one, let's just use white. 300, well, that's past 270, but before 360, so we could say 300 is about there. So essentially, we're saying that the cos of 90 is equal to 0. The cos of 100, we don't know its exact value, but it's definitely negative. And the cos of 300, we don't know its exact value, but it's obviously positive. So that means that in order of size from smallest to biggest, cos 100 comes first because that's negative, then cos 90 because that's 0, and then cos 300, and we're done there. Now let me just show you the other way using the cast diagram. If you wanted to try it with a cast diagram, you would draw your cast diagram like this, and you'd realise that, well, 90 is in the first quadrant, so cos 90 would be here. 100 is after 90, so it's in the second quadrant. And 300, well, that goes 90, 180, 270. So 300 is here. And the other thing you would have to tell is that the cos of 90 you would have to know is equal to 0. But you also know that this is positive and this is negative, so therefore you get your 0, positive and negative from the cast diagram. SQA National 5 Maths 2024 Paper 2 Question 11. Solve the equation 17 sin x plus 1 is 9. So it's a trig equation. I'll take away 1 for both sides. 17 sin x equals 8. And divide by 17. Sin x is 8/17. So I do the inverse sine of 8/17. It is positive, so that's great. Make sure my calculator's in degrees. Shift sine 8/17. That's 28.07. I'll leave it as an 07 or 28.1. And then we do a cast diagram. Now, our sine is positive, so it's these two angles. So it's x equals 28.07 degrees, or 0.1, and x equals 180 minus that. $151.93. And we're done there.
SQA National 5 Maths 2023 Paper 2 Question 11. Anna has a grandfather clock in her house. The height of the tip of the hour hand above the floor in centimetres is given by h is 20 cos x plus 147. Trigonometry equation then, where x is the angle the hour hand was rotated since 12 o'clock. Calculate the first two values for x for which the tip of the hour hand is 150 centimetres above the floor. So I'm just saying that 20 cos x plus 147 is equal to 150 because that's the height. So we now need to solve that. So taking 147 for both sides, we get 20 cos x is equal to 3. Dividing through by 20 then, cos x is 3/20, and then we use the inverse cos. Inverse cos of 3/20 in a calculator is 81.373. 81.373, or we could just say what that is, 81.4 degrees, but that's 1. So now we need our cast diagram. Our cos was positive, so we need to do 360 minus 81.4. 278.6 degrees.
A wind turbine has 3 blades as shown, and it gives you this equation for the tip of the blade, and it says calculate the height of the tip of the blade when it's turned for an angle of 60. So I have to substitute 60 in. So for part A, I can just write h equals 40 plus 23 cos 60. That's 40 plus, now the cos is 60, use your calculator as 0.5. So you would get 0.5 times 23, which is 11.5. So you get a final answer of 51.5 metres. Part B says the minimum height of the tip of the blade A above the ground. Now this is a little bit tricky to think about, but we've got an equation here. 40 plus 23 cos x. Now if you think of a cos graph or anything else, you'll realise that the minimum the cost goes down to is -1. So it's really just asking you to realise that, and you've got h would then be 40 plus 23 times -1, so minus 23, which is equal to 17 metres. Now, if you're going to do part A and part B, don't worry, we only have 1 mark. Part C is the meat and potatoes of this. Calculate the values of x for which the tip of the blade is 61 metres above the ground. So, for part C, h is equal to 61. So I can write 40 plus 23 cos x equals 61 and solve that equation. So taking away 40 for both sides, 23 cos x equals 21. So cos x is 21 over 23. So then we can work out x. X is the inverse cos of 21 over 23, which is 24.1 degrees. But that's not the only answer, remember, because if we draw a cast diagram, we've got A and C, which is 360 minus, so we could have x is also equal to 360 minus 24.1, which is 335.9 degrees.
SQA National 5 Maths, 2023, paper 1, question 11, sine 30 is a half, calculate the value of sine 330. So I usually just use a cast diagram for this. It's a related angle. So remember with this quadrant here, quadrant 1, then quadrant 2 tells you it's 180 minus 30 is the related angle. That's 180 plus the angle, so 180 plus 30. And this last one is 360 minus 30, which is the one we want because that is 330. So now we need to decide, well, in this quadrant, is the sign positive or negative? So here it's positive, and here it's positive, A and S, and here is negative. So the sine of 330 is just the negative of the sine of 30. So the sine of 330 is simply minus 0.5, and we're done there.
SQA National 5 Maths 2024, paper 2, question 16. Express 3 cos squared x minus 1 in the form a plus b sine squared x. What the hell? That looks tricky, doesn't it? I bet you everybody thought that one was tricky. There's 2 you need to know at National 5. Sine divided by cos is tan. Well, we've got a square, so that. Or sine squared plus cos squared equals 1. So we're going to use that. If I've got sine squared x plus cos squared x equals 1, and my answer, a plus b sine squared x, doesn't have a cos squared x in it. But I'm going to have to get rid of this cos squared x. So I'm going to have to rearrange this to work out what cos squared x is. Well, cos squared x is equal to, take away sine squared x, 1 minus sine squared x. So I can now just sub that in. So 3 cos squared x minus 1 equals 1 minus sine squared x, with minus 1 sitting on the end. That's 3 times 1 is 3, minus 3 sine squared x, minus a 1. 3 minus 1 is 2, 2 minus 3 sine squared x. And we're done there.
SQA National 5 Maths 2022, paper 2, question 13. Another trigonometric identity question. Simplify sine x plus 2 cos x over cos x. Okay, so we could split this up into 2 separate fractions. We've got sine x degrees over cos x degrees plus 2 cos x degrees over cos x degrees. And then we can deal with each fraction individually. You get a mark just for separating them out, by the way. Sine x divided by cos x we know equals tan x. Cos x divided by cos x, well, that just simplifies to 1, that we cancel, so I've got plus 2 left over for our final answer. Okay, mean and standard deviation, SQA National 5 Maths 2022, paper 2, question 5. School netball team recorded a number of sit-ups each player completed in a minute. The numbers for the 7 players were this. Calculate mean and standard deviation, and then there's a comparison question to do at the end, but let's do part A first. So for part A, just recall from the front of the exam paper, the standard deviation is the square root of the sum of x minus x bar squared all over n minus 1. You could use the other formula, but I never do, so I'm just going to draw my table. my table goes x minus x bar from the start of the formula, and then x minus x bar again squared. And the goal here, remember, is I put all my x's down the side, I then take away the mean, I then square and get a final total which replaces the top of the formula. So the first thing we're going to do is calculate the mean by adding all these up. So let's just get my calculator ready. 182 is our total. So our mean, which we can just say is x bar, is 182 divided by 7, because there's 7 numbers, which is 26. And we get a mark for calculating the mean. So now in the middle, we take away 26 from each of the numbers. So we get 29 minus 26 is 3, then we get 27 minus 26 is 1, and then minus 2, and then 5, and then minus 4, then minus 7, and then 4 again. Squaring each of the numbers, you get 9, you get 1, 2 2s is 4, 5 5s is 25, 4 4s is 16, 7 7s is 49, and 4 4s is 16. 9, 1, 4, 25, 16, 49, and 16 gives you another mark for getting that column. We then add all these up. 120, and that's our key number, because now our standard deviation is equal to the square root of 120 divided by 6, because there's 7 numbers, so 1 less is 6. Square root of brackets 120 divided by 6 is 4.47, or 4.5 if you prefer. I'll just leave it as 4.47. And that's us done. We've calculated the mean and standard deviation. Let's move to part B. So some players in the school's hockey team also recorded the number of sit-ups they completed in a minute. They gave their mean as 29 and standard deviation is 3.2. Make 2 valid comments comparing the number of sit-ups of the players in the netball and hockey teams. So comparing the mean first, we always have to say on average. So I'm just going to write that down straight away before I have a look. And the netball team's mean was 26. The hockey team is 29. So on average, the hockey team completed more sit-ups. In a minute. And we could say because 29 is bigger than 26. So there's a mark there, and then comparing the standard deviation, which is all about consistency. The netball's team was 4.47, and the hockey team's 3.2, which means the hockey team was more consistent because it's a smaller number. So we just say the number of sit-ups was more consistent for the hockey team. And we could say because 3.2 is less than 4.47. Now be very careful with this one. You have to mention the number of sit-ups for the second standard deviation to get your mark, because you need to show that you know what. And now I mean a standard deviation question this time in the SQA National 5 Maths 2017 paper 1, question 12. So again, a non-calculator one. Gym members are asked to fill in a questionnaire to rate the quality of the service provided. They're asked to rate on a scale of 1 to 6 as shown. 5 gym members picked 1, 4, 6, 3, 6. And its simplest form of standard deviation can be written as a root b over 2. Calculate the values of a and b. Do not be worried that we've done that. That means that we're just combining this with surds. But your step, it's mentioned standard deviation. So again, you're going to calculate standard deviation. So step 1 is to draw my table, but I get the formula from the start of the exam paper first. The sum of x minus x bar squared over n minus 1. That's a little bit messy. But our table, if you recall, is always the same. X minus x bar, and x minus x bar again, squared, all from the top. And we can write down our numbers, 1, 4, 6, 3, 6. 1, 4, 6, 3, and 6. We add them up at the bottom. So being very careful, 6, 7, 8, 9, 15, 19, 20. So our total is 20, which means our mean is 20 divided by 5, which is 4. In the middle, we take away our mean then. So 1 minus 4 minus 3, 4 minus 4 is 0, 6 minus 4 is 2, 3 minus 4 is minus 1, 6 minus 4 is 2 again. And then the last column was square. So that gives me 3 3s is 9, 0 zeros is 0, 2 2s is 4, 1 1s is 1, 2 2s is 4. And then we add them all up. 9, 13, 14, 18. There's our key number there. Already we've got a mark for calculating the mean, a mark for getting x minus x bar, and then we get another mark for substituting that into our standard deviation, which is the square root of 18 over 4. One more mark left just for using surds. So we have to leave it in the form a root b over 2. So we need to simplify this in some way. So we can separate that into two square roots, square root of 18 over the square root of 4. I need two numbers at times together to make 18, one of them a square number, so that's 9 times 2, and the square root of 4 is 2, so that leaves a final answer. Square root of 9 is 3, root 2 I can't do anything with, all over 2, our final mark, 3 root 2 over 2. Refer back to my surds in the numeracy unit to get more work on surds.
SQA National Maths 2024, Paper 1, Question 5. The prices in pounds of cameras in a shop are displayed below. Find the median in interquartile range. So median in interquartile range means we put them in order. So let's just put them in order. So 150, 160, 190, 210, 230, 240. Oh, that's nice. I'll put them in order for us. So the median's the one in the middle when they're in order. So I've got 1, 2, 3, 1, 2, 3. The middle is between 190 and 210. Now I can see easy that's 200. If you can't, you can just add them up and divide by 2. So 210, 310, 400 divided by 2 is 200, like I just got. I'll write that's the median in a minute, but then our quartiles is just the middle of the first half and the middle of the second half. So it's only up to here. So we've got 1, 2, 3 numbers, and then we hit 200. So that gives me 230. And then the middle of the first half, 1, 2, 3 numbers is 160. So the median is 200, and the interquartile range is 230 minus 160. So that's 40, 50, 60, 70. Just to be clear, £200. And then interquartile range, you could probably have a pound sign on that, but maybe not. So we'll just leave that there. I'll put a pound sign just to be on the safe side. On our website, the sample of camera prices have a median of 195 and an interquartile range of 73. Make two valid comments. So for median, it's on average. So we've got 195 and 73, and I got 200. So on average, and what's this about? Price of cameras in a shop. And this is a website. So on average, camera prices are, and let's look at a shop, more expensive in shops. Or bigger, more expensive or bigger in shops. And that's since, I always like this, £200 is bigger than 195. Now to compare the interquartile range. So that is a statement about variability. So my interquartile range for in shops was 70, but online it's 73. So the prices of cameras vary more online, since £73 is bigger than £70. Now, if you don't like to use vary, you can use consistency, and you would say the price of cameras is more consistent in shops, since £70 is less than £73.
SQA National 5 Maths 2023, Paper 1, Question 9. The magazine company conducted a survey of the ages of its readers. A sample of the 10 readers is shown. calculate the median and interquartile range. Oh, that's interesting. So now we need to put them in order to get the median and the interquartile range. So being very careful here. So in order, I've got 31, and then I've got 33, 35, 36, 38, 41, 41 again, 42, 47, and 55. So the median's the one in the middle, but it was 10 numbers. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4. Will be 2 in the middle. So it's in between 38 and 41. That would be 39. 39.5. Now there's two ways to work it out. Add them together and divide by 2, or realise it was 3 in between them, so 3 divided by 2 is 1.5, so just add 1.5 on. Now to get your quartiles, I want the middle of the left, so there's 1, 2, 3, 4, 5, so it's a 1 here, which is 35. That's quartile 1. And the middle of the right, there's 5 again, so it's the middle of those 5, so that's quartile 3. So we can say our median is 39.5 years, and our interquartile range is Q3 minus Q1. 42 minus 35 is 7 years. Okay, part B is going to be a statement question. It's going to say to us, a newspaper company conducted a survey of the age of its readers. The median was 41 and interquartile range was 9. Make 2 valid comments. So if you're comparing the median, it's just the same as comparing the mean. It's on average is your key words. And if you're comparing the interquartile range, that's the same as standard deviation. It's about variation in the age. So comparing the median first. On average is my key word. I always need that. And then just looking at the newspaper against the magazine. The newspaper was 41. The magazine was 39. The age of newspaper readers is higher. And we can say since 41 is bigger than 39.5. Now to compare an interquartile range, we'll just talk about variability. So I got 7 for the magazine, and for the newspaper it's 9. So the age of the readers of magazines is less varied than newspapers. And the varied is the key word. The age of magazine readers is less varied than the age of newspaper readers, since 7 is less than 9. And we're done there. Line of best fit, SQA National Maths 2019, paper 1, question 6 had this one. It says the fuel consumption of a group of cars is recorded, and the scatter graph shows the relationship between the fuel consumption, F, on the y-axis, kilometres per litre, and the engine size, E, in litres of the cars. The line of best fit is drawn. Find the equation of the line of best fit in terms of F and E. Give your equation in simplest form. And then for part B, engine size 1.1, use your equation to find the kilometres per litre he should expect to get. So part A first, straight line question. We need 2 points to find the gradient, and then y minus b equals mx minus a. Now it's not told us any points here, so we need to go up to the graph and find them ourselves. So you just look for real points on the graph. So don't pick this, that's not on the graph. Don't pick this. Don't pick this that you can't read. Look for one you can read. There's one there, and there's one there. So our first point I'm going to use is this one, and that is looking here 3.54, so it's along 3.5 and up 8. So I can take a note of that here, 3.5 and 8. And similarly, this one here I can see is 1.514. Once you get your 2 points, you can work out your gradient. So remember, gradient is y2 minus y1 over x2 minus x1. So I'll call that
x1 and y1, and this one x2 and y2. So we've got 14 take away on top over 1.5 minus 3.5. Now I should be expecting a negative answer here because the slope is sloping down the way. So 14 take away is 6, 1.5 minus 3.5 is minus 2, which gives me a gradient of negative 3. 6 divided by negative 2. Then we're going to use y minus b equals mx minus a. So I'll just call one of the points a and b. Let's do this one, but you can use the other one. So y minus b is mx minus a. So we've got y minus 8 equals minus 3x minus 3.5. Get a mark for getting that far, and then fixing it all up, y minus 8 equals minus 3x. Minus times a minus is a plus. 3 times 3 is 9, plus 1.5 is 10.5. And then that means y equals minus 3x plus 18.5. But we need to swap our axes for f and e. So f equals minus 3e plus 18.5 for our final mark. Part B says use your equation to work out how many kilometres per litre he gets, which is f, and his engine size is 1.1. So for part B, E equals 1.1. So that means that F equals minus 3 times 1.1 plus 18.5. That equals minus 3.3 plus 18.5. And if you can't do that sum, you can just at the side do 18.5 minus 3.3 to get 2. 8 minus 3 is 5 and 1. So you get 15.2. And the units were given to us kilometres per litre. Kilometres per litre. And we're done there for our final mark.
That's 5 Maths 2016, paper 1, question 5 on line of best fit. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age, months, and the weight in kilograms of the calves. So weight up top, age on the side. The line of best fit is shown. Point D is a 3-month-old calf and weighs 100 kilos. Point E is 15 months and 340. Find the equation of the line of best fit. So this is straight line in context, where all we've done is changed that y to w and x to a. So it's still the same idea. We need to find 2 points to find the gradient. Then use y equals mx plus c, or y minus b is mx minus a. I use the second one usually. So there's my point D, there, and E. So let's write down the 2 points to start with. D is 3/100. It tells me here. E is 15/340. That tells me there. So I can find the gradient. Remember, gradient is y2 minus y1 over x2 minus x1. So I call one of them x1 and y1, and the other one x2 and y2. I usually make the bigger one x2, y2. Subbing it in, 340 minus 100 over 15 minus 3. That's 240 on the top and 12 on the bottom. 12 goes into 24 twice, so that makes 20 as my gradient. So now the second step is to use y minus b equals mx minus a. That's the way I always do it, so I'm going to not stop there. A and b is just one of the points, so I always use any one, but the small one's easier. A and b. So a is 3, b is 100. Y minus 100 equals m, which is 20, x minus 3. Expanding my bracket then, y minus 100 equals 20x. 20 times 3 is 60, so minus 60. It says minus 100 on this side, so if I add 100 to the other side, I'll have y on its own. So y equals 20x. 100 minus 60 is plus 40. And usually I'd be done there with straight line, but now we need to look at what it's telling us in the question. It's w and a. So I write w for y equals 20a for x plus 40. And that's part A done for all our marks. Part B, use your equation for part A to estimate the weight of a 1-year-old calf. So let's see what A and W represented. W is weight in kilograms, age is months. Oh, we're trying to trick us here. 1-year-old means A equals 12 because age is in months. So W equals 20 times 12 plus 40. 20 times 12, well, I'll do 20 times 10 is 200. 20 times 2 is 40, so that gives you 240 plus 40, which is 280 kilograms. And we're done there.
This has been Clever Maths. Hopefully you found this useful. It's went through every single topic, question by question by question, for the maths exams in 2025. Take care, stay safe, and goodbye.